Selamat datang di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan perdagangan aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia. Selamat datang di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan perdagangan aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia. Selamat datang di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan perdagangan aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia. Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan perdagangan aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast-moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera bagi kita semua. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan. Kami ucapkan terima kasih dan selamat datang. Yang terhormat kepada Bapak Firnanda Hapsara, Bapak Dominikus Niko, Bapak Sigit Purwadi, Bapak Fauzan Latif selaku Direktur Cita Indonesia, yang kami hormati Ibu Yen Yen selaku Direktur ITPSA Indonesia, yang kami hormati Bapak Nanung, Dr. Strategi, Dr. Joseph selaku narasumber pada siang hari ini. Dan sekali lagi kami ucapkan selamat datang kepada seluruh hadirin dalam acara launching Cita ITPSA, Strategi Optimalisasi Nutrisi Bahan Protein Nabati menggunakan Exogenous Enzyme pada pakan. Puji syukur kehadirat Tuhan Yang Maha Esa, karena hanya dengan rahmat-Nya kita dapat berkumpul pada hari Selasa 14 Juni 2022 di tempat ini dalam keadaan sehat walafiat. Acara ini merupakan launching produk Capsozyme yang merupakan kolaborasi ITPSA sebagai produsen dan Cita Indonesia sebagai distributor. Bersama saya Atiko Rozana Amalia yang akan menemani Bapak dan Ibu sekalian dalam acara siang hari ini. Pada siang hari ini izinkan saya untuk menyampaikan susunan acara sebagai berikut. Yang telah kita laksanakan, lunch dan juga registrasi, lalu ada play video Cita dan ITPSA, lalu akan dilanjutkan materi pertama oleh Insinyur Nanung Danardono SPT MP PhD IPM ASEAN Eng Gajah Mada University, lalu dilanjutkan materi kedua oleh Sergi Karne DVM PhD Technical Director ITPSA. Lalu akan dilanjutkan dengan tea break, dan untuk materi yang terakhir akan disampaikan oleh Dr. Joseph Maskare, Business Development Manager ITPSA. Selanjutnya untuk sesi yang terakhir kita akan ada question and answer yang akan dibimbing oleh Ibu Yen Yen selaku Direktur ITPSA Indonesia. Selanjutnya ada lucky draw dan seremonial, serta yang terakhir ada thank you note oleh Bapak Dominikus Niko dari Cita Indonesia. Izinkan saya, Atiko, untuk menyampaikan apa itu ITPSA dan apa itu Cita Indonesia. ITPSA, Industrial Technica Pecuaria SA, perusahaan asal Spanyol sejak 1968, dan merupakan produsen suplemen pakan ternak terkemuka. Produk ITPSA berfokus pada produk dasar dan alami yang berbasis pada hasil penelitian ITPSA sendiri untuk meningkatkan hasil produksi dan profit yang maksimum serta berkelanjutan. Penelitian, pengembangan, dan inovasi adalah komitmen kuat ITPSA dan juga berkomitmen untuk memberikan jaminan kualitas kepada konsumen melalui sertifikasi FAMI-QS maupun ISO 9001. Cita Indonesia sebagai mitra pilihan hadir untuk turut andil dalam membangun industri peternakan yang lebih berkelanjutan melalui penyediaan solusi nutrisi dan kesehatan hewan. Dengan visi misi Cita Indonesia dapat tumbuh bersama pelanggan dengan menyediakan produk imbuhan pakan atau feed additive dan solusi yang dibutuhkan serta bermanfaat untuk pelanggan. Cita Indonesia juga menjalin hubungan yang baik dengan prinsipal, salah satunya adalah ITPSA. Cita Indonesia dan ITPSA bersinergi untuk mencapai tujuan bersama. Dengan memiliki fasilitas yang lengkap, laboratorium, manufacture, warehouse, research and development yang mumpuni, memastikan bahwa kami terus berinovasi untuk bisa menghasilkan produk yang aman, berkualitas, dan terus berusaha memberikan pelayanan yang terbaik. Cita Indonesia siap menjadi partner untuk solusi nutrisi dan kesehatan ternak Anda. Tanpa berlama-lama lagi, langsung saja saya akan membacakan untuk pemateri pertama. Izinkan saya untuk membacakan kurikulum vitae beliau. Dengan nama Insinyur Nanung Danardono SPT, MP, PhD, P, IPM, ASEAN, Eng Gajah Mada University. Lahir di Yogyakarta 23 Desember 1973. Dengan pendidikan S1 Faculty of Animal Science Universitas Gajah Mada, Magister Animal Science Studi Program Universitas Gajah Mada, Dr. College of Medical Veterinary and Life Sciences MVLS, University of Glasgow, Scotland, UK. Dan posisi saat ini beliau yaitu Lecturer and Researcher di Faculty of Animal Science Universitas Gajah Mada. Dengan topik penggunaan Exogenous Enzyme untuk memaksimalkan potensi genetik ternak unggas. Langsung saja saya perkenalkan kepada Bapak Nanung, kami persilahkan.
Assalamualaikum warahmatullahi wabarakatuh. Ibu Bapak yang saya hormati, siang hari ini saya akan sedikit berbincang mengenai enzim, utamanya penggunaan enzim pada unggas. Barangkali bisa dibantu PPT-nya, biar lebih fokus berbicaranya. Slide pertama. Yap, oke, thank you. Baik, Bapak Ibu, saya akan menyampaikan materi mengenai enzim dan betapa pentingnya penggunaan enzim pada ternak unggas. Nah, mohon maaf, apakah pernah membaca ini, Managing Gut Health Through Nutrition? Ada yang pernah baca ini? Ini paper yang sangat terkenal oleh Menggunakan, salah satu peneliti dari University of New England, Armidale, Australia. Beliau membuat publikasi yang sangat penting, sangat menarik dan diikuti oleh banyak peneliti yang lain membahas mengenai penggunaan feed aditif pada ternak unggas. Nah, ini kenapa penting? Karena ternyata hewan-hewan ternak unggas yang memiliki potensi genetik bagus ternyata tidak bisa tampil maksimal ketika dipelihara di tempat-tempat yang tidak optimal. Kalau penelitian seperti, mohon maaf kalau kita boleh menengok, seperti ROS 308 misalnya, ayam broiler strain ini ternyata dia mampu mencapai bobot badan, ini penelitian 2014 itu, jantan 5,5 kilo bobot badannya, 5,5 kilo. Tetapi kemudian 4 tahun berikutnya naik jadi 5,7 kilo. Itu potensi genetik sesungguhnya. Tetapi ketika dipelihara di tempat yang tidak ideal, ternyata sangat sulit mencapai itu. Kenapa tidak ideal? Ternyata memang ada banyak problem. Di antaranya di papernya Menggunakan ini disebutkan bahwa ada 640 spesies mikroba di saluran pencernaan ternak unggas. Dan mereka ada yang patogenik, ada yang beneficial, dan mereka hidup bersama. Tidak ada masalah ketika mikroba yang baik, yang beneficial itu lebih dominan. Tetapi menjadi problem ketika mikroba-mikroba yang patogenik itu lebih dominan. Nah, maka kemudian sangat penting kita melakukan pendekatan penggunaan enzim pada pakan. Kenapa demikian Bapak Ibu? Ternyata kalau kita cermati lebih detail, pakan ternak unggas itu kan didominasi oleh bahan pakan sumber energi dan protein. Bahan pakan sumber energi seperti jagung yang banyak dipakai di Amerika dan tempat kita, itu kan dikenal sebagai the king of cereals. Kemudian juga kalau di Eropa mereka tidak menggunakan jagung tapi menggunakan gandum. Kenapa menggunakan gandum? Karena jagung bisa tumbuh di Eropa tetapi tidak maksimal. Karena fotosintesis tidak bisa maksimal karena sinar matahari kurang panjang, maka kemudian tidak optimal. Maka kemudian mereka menggunakan gandum. Nah ternyata bahan pakan seperti jagung, kemudian gandum, ternyata selain memiliki kandungan energi yang sangat tinggi, ternyata juga menyimpan problem yang luar biasa, terutama terkait dengan NSP. Bapak Ibu, kita tahulah yang namanya karbohidrat itu kan macam-macam. Ada yang namanya amilem atau starch, ada yang non-amilem. Nah, di dunia peternakan ternak unggas kita tahu bahwa saat ini ada dua pembagian karbohidrat, satu amilem, kemudian satu kelompok yang non-amilem, yang kita kenal dengan istilah non-starch polysaccharide non-fatty. Nah, NSP ini macam-macam, ada yang dalam bentuk beta-glukan, hemiselulosa, silan, arabinoksilan, ada pentosan, pektin, semanan, asam fitat, dan seterusnya. Nah, ini ternyata judulnya itu kan karbohidrat, tetapi menyimpan problem. Ketika di bahan pakan seperti jagung dan gandum ini banyak mengandung NSP, ternyata membuat viskositas atau kekentalan menjadi naik. Bapak Ibu barangkali tidak pernah mengalami seperti yang kami alami ketika kami kecil, ketika pengen membuat layang-layang untuk membeli lem, masa itu cukup mahal. Maka kemudian kami menggunakan pati kanji, kemudian diletakkan di sendok, dikasih air, diaduk, kemudian diletakkan di atas kompor. Kira-kira apa yang kemudian terjadi? Ada yang tahukah? Ada yang pernah mengalami kah? Bapak Ibu kalau meletakkan gandum di sendok, dikasih air, diaduk, letakkan di atas kompor, apa yang terjadi? Lengket? Enggak. Kenapa tidak? Karena kompornya tidak dinyalakan. Tapi begitu kompornya dinyalakan jadi panas, maka kemudian jadi lem. Nah, itulah yang terjadi di saluran pencernaan ternak unggas. Suhu ternak unggas itu berapa tuh suhu tubuhnya? Lebih tinggi atau lebih rendah daripada manusia? Lebih tinggi. Maka ketika bahan pakan yang kaya akan NSP, ya, seperti di jagung kan terkenal sangat tinggi kandungan energinya, tetapi NSP-nya sangat tinggi pula. Arabinoksilan terutama sangat tinggi, belum lagi beta-glukan dan yang lain. Ternyata baik gandum maupun jagung maupun gandum ternyata juga mengandung NSP yang sangat tinggi. Nah, maka kemudian ketika mereka dikonsumsi oleh ternak unggas, itu menyebabkan laju pakan di dalam saluran pencernaan menjadi lambat. Kenapa? Karena NSP ini membuat viskositas menjadi tinggi. Digesta itu menjadi lengket. Nah, kenapa lengket? Karena ada NSP. Nah, begitu lengket, maka tentu menyebabkan laju pakan di dalam saluran pencernaan menjadi sangat lambat. Nah, maka masa tinggal pakan atau digesta dalam saluran pencernaan menjadi lebih lama. Nah, karena lebih lama ini ternyata menstimulasi pertumbuhan dan populasi mikroba patogen. Nah, namanya juga patogen, maka efeknya luar biasa. Nah, Bapak Ibu yang saya hormati, di kedelai juga begitu. Ternyata kedelai itu memang proteinnya tinggi, tetapi juga menyimpan masalah. Jangan dikira ternyata di bagian luarnya, Bapak Ibu pernah makan kedelai mentah apa tidak? Pernah makan jagung mentah? Pernah ya? Tadi kita makan jagung mentah, tapi dimasak. Tetapi kalau jagung pipilan mentah, pernah mengunyah? Nekat dikunyah itu pernah? Kira-kira apa yang terjadi kalau kita kunyah langsung? Pecah. Yang pecah itu ternyata gigi kita. Kedelai juga gitu, kedelai mentah kalau kita kunyah, yang remuk itu ternyata gigi kita, bukan kedelainya. Kenapa? Karena jagung, kemudian kedelai itu dibungkus ya, oleh bahan-bahan yang ternyata suka dicerna oleh saluran pencernaan kita. Kenapa? Karena kita tidak punya enzim yang mencerna NSP. Nah, maka Bapak Ibu, ternyata ketika kita menggunakan enzim ini bisa menyelesaikan masalah. Enzim tentu macam-macam, ya tergantung substrat yang akan dipecah itu apa, begitu. Namun yang jelas ketika kemudian di pakan yang kaya akan karbohidrat seperti gandum atau baik wheat, barley, oat, triticale, atau kemudian juga jagung yang kaya akan NSP, kemudian ditambahi dengan enzim yang mencerna NSP. Jadi kita menggunakan NSP-ase, ternyata kemudian masalah-masalah yang terkait dengan NSP menjadi dikurangi. Bapak Ibu, apa sih efek buruk? Ya. Ini barangkali yang paling penting. Apa sih efek buruk? Kalau di bahan pakan itu buahnya ada NSP-nya. Ya. Jadi Bapak Ibu, ada rangkaian problem yang tidak sepele ternyata. Jadi ketika di pakan itu banyak NSP-nya, maka kemudian laju pakan di dalam saluran pencernaan menjadi sangat lambat. Begitu sangat lambat, maka masa tinggalnya jadi lebih lama. Nah, karena lebih lama, maka kemudian menstimulasi pertumbuhan mikroba patogen. Mikroba patogen, kenapa namanya patogen? Karena mereka menghasilkan metabolit. Metabolit itu apa ya? Metabolit adalah senyawa yang dihasilkan oleh makhluk hidup bersel satu. Kalau manusia, hewan menghasilkan ada feses, urin, keringat, dan yang lain-lain. Tetapi kalau makhluk hidup bersel satu, maka mereka mengeluarkan senyawa yang disebut dengan istilah metabolit. Metabolit itu macam-macam, ada yang bermanfaat, ada yang tidak bermanfaat. Nah, patogen dikatakan sebagai patogen karena mereka menghasilkan metabolit yang berefek buruk. Ada metabolit yang berefek toksik, maka dikenal dengan istilah toksin. Nah, toksin ini seperti senyawa amin, kemudian lipopolisakarida, juga amonia, ternyata ketika menyentuh dinding usus, ternyata menyebabkan luka. Nah, kalau luka berlanjut bisa menjadi infeksi. Kalau infeksi berlanjut jadi radang. Kalau radang berlanjut bisa sampai ke kematian jaringan. Bapak Ibu pernah membaca atau mungkin pernah fokus ke penyakit NE, necrotic enteritis? Necrotic enteritis itu apa? Necrotic berasal dari kata nekrosis, kematian jaringan. Enteritis dari kata enter dan itis. Enter itu yang dimaksud adalah saluran pencernaan. Itis adalah radang. Jadi radang di usus yang sampai ke kematian jaringan. Bapak Ibu masih ingat usus unggas, terutama usus halus seperti duodenum, jejunum, ileum, itu isinya apa tuh dindingnya? Ada sel apa saja di situ? Ada satu sel yang berfungsi sebagai penyerap nutrien. Ada absorptive cells. Yang kedua ada goblet cells. Yang fungsinya adalah menghasilkan mukus. Mukus atau lendir tujuannya adalah melapisi permukaan usus agar tidak langsung tersentuh oleh toksin. Juga ada sel-sel yang menghasilkan enzim dan hormon. Nah Bapak Ibu, ternyata kalau populasi mikroba patogen itu sangat tinggi di dalam saluran pencernaan, maka jumlah toksinnya sangat banyak. Nah maka tubuh melalui goblet sel akan merespon dengan menghasilkan mukus. Semakin banyak toksinnya, semakin banyak mukus yang dihasilkan oleh goblet sel. Dan kadang-kadang kalau jebol sampai ke diare. Maaf, Bapak Ibu pernah diare kah? Pernah ya. Kemudian kalau berobat, apa pertanyaan standar yang diajukan oleh dokter? Ingat, ada lendirnya apa tidak? Mohon maaf, jangan seperti mahasiswi kami di UGM, kadang-kadang mereka berobat itu milih-milih. Mereka milih dokter yang masih muda, ganteng, kaya, belum menikah. Terus ketika berobat, maaf ibu sakit apa? Maaf dok, saya masih mahasiswi, jangan panggil ibu, adik aja. Sakitnya apa? Oh saya diare. Ada lendirnya apa tidak? Tidak, padahal ada. Kenapa mengatakan tidak? Karena malu sama dokternya. Nah, mohon maaf. Kenapa ada pertanyaan standar ada lendirnya apa tidak? Karena kalau ada lendir maka ada indikasi berarti ada over secretion of mucus. Nah, kenapa ada over secretion of mucus? Karena banyak toksinnya. Maka dokter akan berikan obat antibiotik. Tetapi kalau tidak ada lendirnya, maka dokter tidak boleh berikan antibiotik, tapi memberikan obat-obat yang lain yang mengurangi atau membantu absorpsi cairan di dalam usus. Nah, jadi ketika banyak toksinnya, maka risiko kena luka, kemudian infeksi, kemudian inflamasi atau radang, bahkan kematian jaringan menjadi semakin tinggi. Nah, maka kalau kemudian yang terkena itu adalah absorptive cell pada microvilli, pada fili-fili, maka pertumbuhan fili menjadi tidak maksimal. Mohon maaf, karena semakin banyak toksinnya, maka lendir yang dihasilkan akan semakin banyak. Dan kalau lendir itu tebal, maka dia menghambat pertumbuhan fili. Fili jadi nggak bisa tumbuh dengan maksimal. Seperti kalau kita jongkok, kita mau berdiri digondeli apa bahasa Indonesianya? Dipegang jadi nggak bisa tumbuh, nggak bisa berdiri. Begitu pula dengan fili-fili, ketika kepengen tumbuh dengan maksimal, tetapi karena banyak lendirnya mereka nggak bisa tumbuh jadi panjang. Jadi filinya pendek. Maka ternyata kalau filinya pendek, maka jumlah sel-sel yang berfungsi menyerap nutrien menjadi tidak banyak. Apalagi kalau kemudian banyak sel yang luka oleh toksin yang dihasilkan oleh patogen. Nah, maka kalau kemudian alat untuk mengabsorpsi itu terbatas, apalagi filinya pendek, maka jangan berharap potensi genetik sesungguhnya akan tercapai. Kenapa? Karena jumlah mikronutrien yang bisa diserap tidak banyak. Nah, kalau tidak banyak berarti jumlah mikronutrien yang bisa ikut diserap dan ikut metabolisme tubuh jadi tidak banyak. Maka jangan bermimpi potensi genetik akan tumbuh secara maksimal. Nah, kemudian Bapak Ibu juga ternyata selain menghambat pertumbuhan atau proliferasi pembelahan sel dan pertumbuhan sel-sel mikrofilai, ternyata juga kemudian menghambat pencernaan nutrien. Bapak Ibu, jangan lupa kalau di usus itu juga ada sel-sel yang menghasilkan enzim. Nah, jadi kalau banyak sel yang luka, dan yang luka itu adalah sel penghasil enzim, maka kemudian tentunya jumlah enzim yang dihasilkan tidak banyak. Maka kapasitas absorpsinya menjadi tidak maksimal. Nah, kalau fili-filinya tidak tumbuh maksimal, maka kapasitas absorpsinya menjadi tidak maksimal. Ulangi, kalau jumlah enzim yang dihasilkan tidak maksimal, maka kapasitas cernanya menjadi tidak maksimal. Nah, kemudian kalau fili-filinya tidak panjang, apalagi banyak yang luka, maka kapasitas absorpsinya tidak maksimal. Maka sekali lagi jangan berharap potensi genetik sesungguhnya akan bisa tercapai. Apalagi Bapak Ibu, saya pernah baca di beberapa jurnal, ternyata kasus NE, necrotic enteritis, itu efeknya luar biasa. Jadi ketika antibiotik tidak boleh lagi dipakai, kemudian tidak ada lagi tentara yang nyegati patogen, maka kuman-kuman lama ya seperti Salmonella enteritidis, Salmonella typhimurium, kemudian E. coli yang patogenik ya, avian patogenik E. coli, kemudian Campylobacter jejuni, ternyata kemudian tumbuh lagi, merusak lagi. Dan ternyata kerugian secara ekonomi yang disebabkan karena NE sangat tinggi. 0,05 US dollar per ekor, ini untuk yang klinikal. Yang tanpa diagnosis 0,09, luar biasa. Besar sekali kerugiannya. Maka memang kemudian sangat penting untuk menyelesaikan masalah ini. Banyak pendekatan yang dilakukan, Bapak Ibu. Ini memang diunggas begini. Kalau di ruminansia kan sekarang berbeda ya. Ruminansia kan sekarang PMK. Dan PMK ini mirip NE, sporadik, cepat sekali dan sangat masif. Nah, ternyata yang NE ini juga begitu, sangat masif. Nah, maka kemudian harus diselesaikan. Bapak Ibu, enzim ini menjadi salah satu kunci keberhasilan peternakan unggas. Kenapa? Kalau enzim dipakai, jadi ada istilah Exogenous enzyme, jadi enzim yang ditambahkan dari luar, itu akan memperkaya jumlah enzim yang ada di dalam saluran pencernaan. Kenapa ini penting? Karena ternyata tubuh ternak unggas tidak menghasilkan semua enzim yang dibutuhkan untuk mencerna semua komponen yang ada pada bahan pakan. Di bahan pakan kan tidak hanya protein, karbohidrat, lemak, tapi ada bahan-bahan yang lain yang tidak tercerna. Kenapa tidak tercerna? Karena ternak unggas tidak menghasilkan semua enzim. Termasuk fitat, ya, fitat itu kan banyak di jagung. Bapak Ibu, jagung itu kan energinya tinggi ya. Lalu apakah berapa energi jagung? Berapa kandungan energi jagung? 3.350-an. Apakah dijamin semuanya bisa dimanfaatkan? Tidak. Karena ternyata banyak yang kemudian terikat sebagai vital. Nah, maka tidak bisa maksimal. Nah, maka kemudian penting menambahkan vitase. Juga selulase, kemudian silanase ini penting ditambahkan karena ternyata di jagung, kemudian di gandum itu banyak ada silan yang menyebabkan tadi secara tidak langsung populasi patogen itu menjadi sangat luar biasa. Kemudian ini yang produk baru, galaktosidase. Saya coba cermati, ternyata memang ini produk baru, masih jarang penelitian. Ada ya, di berbagai jurnal penelitian ilmiah sudah ada, tetapi belum banyak. Beda dengan enzim-enzim yang lain seperti NSPase, sudah banyak penelitian dan sudah banyak dipakai. tetapi produk enzim seperti galaktosidase ternyata belum banyak ya. Nah Bapak Ibu, bagaimana mekanisme kerja enzim dalam membantu memaksimalkan kinerja pertumbuhan? Bagaimana mekanisme aksi enzim ini membantu ternak mencapai atau mendapatkan potensi genetik sesungguhnya? Ternyata memang sangat bervariasi. Ada yang dengan cara memecah dinding luar. Seperti tadi jagung, kemudian kedelai itu kan sangat keras dinding luarnya. Nah, enzim ini berfungsi sebagai puncturing agent, agen yang membocorkan itu sehingga kemudian enzim bisa masuk penetrasi lebih ke dalam. Nah, Bapak Ibu, ternyata memang ketika dinding sel yang ada pada jagung, kemudian gandum itu sangat keras dan tidak tercerna, ternyata memang betul-betul menghambat. Tapi kemudian ketika ditambah ITPSA, kemudian permukaan jagung menjadi lebih lunak, kedelai lebih lunak, kemudian gandum lebih lunak, bahkan sekamnya pun dibongkar sama enzim ini, maka kemudian berbagai macam enzim yang lain bisa penetrasi masuk ke dalam dan kemudian mencerna menjadi monosakarida, jadi asam amino, dan seterusnya. Bapak Ibu, saya kira masih ingat yang namanya karbohidrat, lemak, protein itu tidak bisa dimanfaatkan. Seperti tadi Bapak Ibu makan siang tadi itu kan kaya akan karbohidrat, lemak, protein. Dan ternyata Bapak Ibu, karbohidrat, lemak, protein itu tidak bisa kita manfaatkan kalau tidak kita makan. Kalau hanya dilihat aja kan nggak ada manfaatnya. Tetapi kalau kemudian kita makan, apakah semuanya bisa bermanfaat? Tidak. Bapak Ibu, yang namanya karbohidrat, lemak, protein itu tidak bisa diserap oleh pori-pori usus kita. Begitu pula karbohidrat, lemak, protein yang ada pada pakan tidak bisa diserap oleh pori-pori nutrien, pori-pori usus. Kenapa? Karena ukuran molekulnya lebih besar daripada pori-pori usus. Maka karbohidrat, lemak, protein hanya bisa dimanfaatkan kalau sudah dicerna. Karbohidrat dicerna menjadi monosakarida. Seperti galaktosidase ini kan mencerna menjadi galaktosa. Galaktosa salah satu monosakarida bersama dengan fruktosa dan glukosa yang ini bentuk yang bisa diserap oleh usus. Nah juga kemudian kalau berbagai enzim ini mencerna itu seperti protease mencerna protein menjadi asam amino, kemudian lemak menjadi asam lemak. Nah, asam lemak, asam amino, kemudian monosakarida ini bentuk yang bisa dimanfaatkan. Nah, enzim itu bertugas untuk mencerna karbohidrat, lemak, protein, termasuk karbohidrat yang tidak tercerna yaitu NSP. Nah, contoh yang sekarang ada banyak di pasaran, ada silanase, beta-glukanase, fitase, galaktosidase, kemudian amilase, protease, ini sudah mulai banyak ya. Tapi memang untuk yang galaktosidase masih sangat terbatas. Di Indonesia saya kira mungkin baru pertama kali ya ini ya, di launching ya. Nah kemudian Bapak Ibu, slide terakhir saya kira, apa manfaat dari penggunaan enzim ini di ternak unggas? Bapak Ibu, secara ilmiah ternyata make sense. Penggunaan enzim dikaitkan dengan pencapaian potensi genetik yang sesungguhnya. Bapak Ibu, kalau kemudian NSP itu dicerna menjadi monosakarida yang lebih bisa dimanfaatkan, kemudian termasuk tadi ada galaktosida bisa dicerna menjadi galaktosa, maka kemudian berbagai problem yang terkait dengan keberadaan NSP dan galaktosida itu menjadi terurai. Contoh misalnya NSP. Kalau NSP kemudian bisa dicerna, maka kemudian viskositas atau kekentalan digesta bisa diturunkan. Nah kalau diturunkan, maka laju pakan atau digesta dalam saluran pencernaan menjadi lebih cepat. Maka masa tinggal pakan di dalam saluran pencernaan menjadi lebih pendek. Nah kalau lebih pendek ternyata membuat mikroba patogen tidak bisa berkembang dengan. Nah maka kalau patogen itu bisa dikurangi populasinya, pertumbuhannya bisa dihambat, maka ternyata efek-efek buruknya bisa dikurangi. Contohnya seperti insiden seperti gut lesion atau luka di usus, kemudian infection seperti infeksi, atau inflammation atau radang, termasuk necrotic enteritis bisa dikurangi. Nah kalau itu dikurangi, kenapa mereka berkurang? Karena toksinnya berkurang. Jadi kalau patogennya berkurang, maka toksinnya berkurang. Kalau toksinnya berkurang, maka insiden-insiden itu menjadi berkurang. Bahkan kalau toksinnya berkurang, goblet sel tidak perlu menghasilkan mukus yang banyak, maka mukusnya tipis. Bapak Ibu mohon maaf, kalau mukus tebal itu tidak hanya menghambat pertumbuhan villi, tapi juga menghambat absorpsi nutrien. Meskipun ternak unggas sudah berusaha keras untuk mencerna makronutrien menjadi mikronutrien, tetapi kalau kemudian mukusnya tebal, maka dia akan menyumbat, pori-porinya akan tersumbat. Sebanyak apapun mikronutriennya tidak bisa diserap oleh dinding usus karena tersumbat. Ia bisa diserap tapi nggak bisa maksimal. Maka begitu digunakan berbagai macam enzim eksogen, maka kemudian secara tidak langsung populasi patogen berkurang. Begitu berkurang maka efek buruk keberadaan toksin, keberadaan patogen dan sekresi atau produksi toksinnya berkurang, maka lendirnya atau mukusnya tipis. Nah kalau lendirnya tipis, mukusnya tipis, maka absorpsi bisa lebih maksimal. Kemudian kalau mukusnya tipis, maka villi-villi bisa tumbuh jadi lebih panjang. Nah kalau semakin panjang villi-villinya, maka semakin banyak pori-porinya. Bapak Ibu ini sangat penting, terutama di jejunum. Maka banyak penelitian dilakukan dengan enzim itu pada jejunum. Kenapa demikian? Kenapa tidak di duodenum? Kenapa tidak di ileum? Bapak Ibu, kenapa kalau penelitian tentang penggunaan enzim ini banyak di jejunum? Apa sebabnya? Satu, jejunum itu secara struktur anatomi dia adalah segmen yang paling panjang. Satu. Yang kedua, dia adalah tempat absorpsi nutrien yang paling maksimal, sangat masif. Maka jika kemudian efek penggunaan exogenous enzyme ini bagus di jejunum, maka absorpsi nutrien diharapkan akan lebih maksimal. Nah, maka kalau kemudian jumlah mikronutrien yang bisa dimanfaatkan lebih banyak, maka mestinya jumlah mikronutrien yang bisa dipakai untuk metabolisme tubuh semakin banyak. Maka semakin banyak nutrien pakan yang bisa dikonversi menjadi daging. Maka pertumbuhannya menjadi lebih cepat dan harapan kita adalah kualitas daging dan berbagai produk peternakan seperti telur juga menjadi lebih bagus. Saya kira demikian. Mudah-mudahan sedikit ini resume ya, ini singkat, maka mudah-mudahan meskipun singkat ada manfaatnya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Bapak Nanu. Saya boleh minta tepuk tangannya sekali lagi untuk Bapak Nanu? Boleh kembali ke tempat, Bapak? Terima kasih kepada Bapak Nanung. Saya yakin Bapak dan Ibu sekalian di sini pasti ingin bertanya-tanya kepada Bapak Nanung ya. Tapi mohon disimpan dulu untuk pertanyaannya karena akan ada question and answer di akhir sesi. Baik, tadi ada sedikit inti dari Bapak Nanung yang memang saya kutip di sini, yaitu ternyata exogenous enzim sangat penting pada unggas ya Bapak Ibu sekalian, karena unggas sendiri itu tidak memiliki semua enzim untuk mencerna berbagai komponen pakan. Nah, maka dari itu kita hadir di sini dengan membawa Capsozyme. Tepuk tangan dulu dong. Selanjutnya masih ada beberapa materi yang menakjubkan dari beberapa narasumber terkemuka kami. Langsung saja biarkan saya untuk membacakan CV beliau. Dr. Sergi Karne, DVM, PhD, MBA, holds a bachelor, a degree in veterinary medicine, a master's, Autonomous University of Barcelona, UAB, for his PhD thesis in veterinary sciences. Between 2003 and 2010, he was associate researcher at UAB, and in 2010, Dr. Karne started working as technical unit manager at ITPSA. Since 2013, he is the global technical manager, being responsible of coordinating activities such as R&D activities, product development, technical support for customers, and regulatory matters. Dr. Sergi Karne has 20 years experience in animal nutrition field. So, please welcome Dr. Sergi Karne, DVM, PhD, Technical Director ITPSA dengan topik optimize soybean meal utilization in quality feed for animal performance.
Good afternoon. Can you hear me? Can anybody confirm, please? Because I don't have feedback. Okay. Okay. I've been confirmed that all of you can hear me. Okay. First of all, good afternoon, everybody. Good morning from Barcelona. I hope that in the near future I will have the opportunity to come to Indonesia and meet you all in person. I want to thank you, the organizers, for the excellent organization of this event. Thank you for having me doing this presentation. Thank you to all the attendees in the venue physically and everybody who is connected online. Thank you all for attending. I want to thank you also to Dr. Manu for the excellent presentation as introduction of the use of enzymes and the challenges of the different feed materials that you have in our diets for animals. Okay, I will do a presentation more focused already in product Capsozyme SB Plus and how it can be used as a valuable tool to optimize the nutritional value of soybean meal, but not only soybean meal, but different legumes as a source of protein, but also as a source of energy, as you will see, in order to improve the quality of feed and animal performance, and in the end also the profitability of the animal production. Okay, next slide, please. Okay, first of all, just as an introduction, we know about the current concern in animal feed industry, which is indeed a concern of the last years. Probably this concern is increasing because of the availability of different feed ingredients. So prices rocketing in the last year. So we all know the importance of the cost of feeds and feed materials in the overall profitability of animal production. But in this case, in the current scenario of uncertainty is even greater. So we know about the energy of the cost of energy, which classically is focused on cereals like corn, wheat, and also vegetable oils. But as we will see, the ingredients classically considered as protein sources are also important in terms of having a valuable, an acceptable energy balance in our diets, like soybean meal, but not only soybean meal, also other alternative sources of legumes and other feed materials. And also nowadays is starting to be important, this environmental cost and how we can contribute to reducing this environmental cost from our industry, from feed industry and animal production industry. And obviously we have opportunities taking account these challenges. So the use of alternative sources of feed ingredients, and as we will explain with Capsozyme SB Plus and generally with different strategies and enzymes to improve feed digestion and to improve nutrient absorption, which eventually results in a better performance of our animals. Okay, next slide, please. Well, this is a question that I make, but obviously you already know the answer. What's your business? What's our business in animal production? Our business is to and focusing in this case in poultry is produce as many tons as meat and eggs per ton of feed. When focusing in the cost of feed ingredients at lower feed cost possible, increasing obviously the profitability. We are here for that also as businesses, but also nowadays also focusing in animal welfare, which is something important and that more and more consumers are asking for this, and also being responsible to do it in a sustainable way, so to have a sustainable production. So we have performance versus profitability when evaluating all these things. Okay, next slide, please. When we focus, in this case, in soybean and other, as we will see, alternative ingredients in animal feed, which is the object of this presentation, and more specifically of the product Capsozyme SB+. We know that soybean meal is the main source of protein in monogastric animal feeds globally, all around the world. Soybean meal has probably the better balance of limiting amino acids in protein of plant origin. We know also the issues of availability in a globalized market where USA, Brazil, Argentina, or India are the main producers and exporters of this soybean meal that everybody is using all around the world. So the global use of this soybean meal is also increasing carbon footprint and has an impact in sustainability, which is something that as industry we are also concerned about. Okay, next slide, please. So, well, we know we have a high dependency on imported soybean meal. So from an environmental, societal, and economic developments, we are requested as a sector to optimize the use and also to explore other alternatives in the use of these feed ingredients. So the objective in the end, as feed industry and in our case to optimize the performance of animals, is to reduce the crude protein, the total crude protein level. Okay, looking this ideal protein in our diets, also exploring, as I have said, replacing as much as possible this soybean meal as a unique source to go to alternative ingredients. So we can consider rapeseed meal, sunflower seed meal, lab beans, fava beans, and other local ingredients that in the different regions we may find. But obviously we have challenges when trying to use alternative sources. So we have high fiber levels and in different profiles than traditionally used in what we consider as the classical corn soybean meal diet. And also these fibers, soluble and insoluble, may induce negative effects, okay, in the digestive processes and having an impact in animal performance and health. Next slide, please. Now to go already to a little bit to the topic. Well, I've always showed this slide with these figures, which for me are really interesting. These ones are taken from the database of FEDNA, so you can take the database of NRC and other international nutritional tables, but more or less the values are similar. In this case, I'm showing the protein digestibility in poultry. As you can see, for different feed materials, I'm showing here soybean, rapeseed, but also corn and wheat. Protein digestibility is quite good, but as you can see, there's room for improvement, and quite improvement indeed. So this improvement can go from 10 to 20% of potential improvement with respect of total protein you can find in this feed ingredient. So it's obvious that there's still room for improvement to try to have advantage of all the ingredients we use in our formulated diets. Next slide, please. But if we go to the energy digestibility in poultry, also in other species, but now focusing more in poultry, you can see that this room for improvement is huge. It's even higher than for protein. As you can see here, you have the gross energy of these feed ingredients, and then you have in the red bars the metabolizable energy of the animals. It's a mean of different literature references of the energy that the animal is really using. So as you can see, there's a huge percentage of energy which is not currently used by the animal. And it's interesting to learn that well, corn, wheat, cereals are always being considered as the source of energy or the main source of energy in the diet. But as you can see, soybean, for instance, has a potential of energy, because gross energy is also very high, a very high potential of being a source of energy for the diets. So this is something that is also that needs to be taken into account. So soybean meal is the most relevant source of protein, but is also an interesting source of energy to be explored. Okay, next slide, please. Okay, well, this concern about how we optimize the use of soybean meal has led the market to provide different sorts of soybeans, differently treated. You have different feed ingredients from full fat soybean meal to the whole, to extruded, to soy protein concentrates and fermented also soybean meals. Well, indeed, these concentrates and these fermented soybean meals in many cases try to do what we are providing with Capsozyme SV Plus, as we will show. So probably it's a more efficient way to provide an enzyme which is more cost effective in order to improve the digestibility of this feed ingredient. But apart from that, and apart from these different presentations of soybean, we also have the problem of anti-nutritional factors. Some of them you all know, trypsin inhibitors and lectins. We also know that with a proper heat treatment, which has to be very well controlled, because otherwise it affects the nutritional value of these feed materials. But in the end, these anti-nutritional factors are thermolabile, so they can be degraded, they can be eliminated. So it's not a major problem if feed ingredients are properly treated. But also we have other anti-nutritional factors which are heat resistant. And here is where I start to talk about alpha galactosides, which is, a term that I hope that in the end of this presentation, it will be already familiar for you. These galactosides, we have been working in strategies to eliminate these galactosides for many years at ITPSA, so we have quite a lot of experience on this. The main galactosides are raffinose and stachyose, I will show a bit later on about them. And they have, as I will show throughout the presentation, a very important impact in the performance of animals. These anti-nutritional factors have not been for a few years in the focus, even though we have been working with them for many years and giving and providing tools to eliminate them to many customers around the world. Okay, next slide, please. Well, this is the starting figure in the presentation. Alpha galactosides. What are alpha galactosides? They are oligosaccharides, so quite different from what we know about these big biopolymers, carbohydrate biopolymers that we may find like arabinoxylans or beta-galactomanans. These are oligosaccharides, but they are present in huge amounts in soybean meal, in soybean in general, but in most of legumes, as I will show. These alpha galactosides are indeed molecules with 3 to 4 sugars, as you can see. I don't know if you can see my point in the screen. I will be showing you a little bit about what I'm speaking about. We have the sucrose, okay, which is a unit of fructose and glucose, and then we have different galactoses. We have different galactoses attached by alpha-1,6 links to this sucrose disaccharide, okay? So we mostly have this raffinose that I was mentioning and the estachiose if we have 2 galactoses instead of 1, okay? So these oligosaccharides are soluble, and they cannot be digested by the animal, okay? And the main problem, as I will show, is that they cause problems to the animal, to the general functioning of the gut in the animal. So these links with galactose is where alpha-galactosidase, which is the important enzyme in this presentation, will act, okay, breaking these links. Then we also have invertase, which is also an activity present in Capsozyme SB+, that breaks this sucrose disaccharide, okay? Invertase, that in the animals is mostly named sucrase, is present in the animals, but not in levels which properly allow the elimination of this sucrose, okay? So, well, as I've said, this galactosidase will break down these links in the galactose. Next slide, please. Well, now I wanted to show you which are the levels of these alpha galactosides and other NSPs in feed ingredients. So here I'm showing some of most relevant typical feed ingredients that you may use in our diets, and then some other feed ingredients a bit more alternative. As you can see, the levels of sucrose are really high in soybean meal, rapeseed, peas. So even in corn and wheat you can find them, but the levels in legumes are high. Raffinose, which is one of the alpha galactosides that I was mentioning, well, you have a presence in soybean meal, in white loop beans here, for instance. It's more residual in other feed ingredients. But then if we go to estachiose, which is another of the alpha galactosides I have mentioned before, here we are having levels really, really high. These values are percentage in the feed ingredient, okay? So as you can see, we find here, for instance, for soybean meal, only with raffinose and estachiose levels, which may be higher than 6%, 7%. And if you take into account raffinose, estachiose, and sucrose, the levels are really high, okay? Also for other feed ingredients like rapeseed, peas, white lupins, okay? Then if we go to Shillans, well, we are more familiar with Chilenaise. Shillans are mostly everywhere, okay? So we have it in wheat, which was originally the diet where Chilenaise was mostly used, but we have learned, and Dr. Manu has also shown in his presentation, how Shillans can also be present at high levels in corn, a cereal that we had always considered as kind of the most ideal cereal for animal nutrition, but obviously there's room also for improvement in corn because we have high levels of Shillans, but also in soybean, rapeseed, and peas. I'm now focusing in this part of Shillans and Chilenaise because I want you to understand the importance of alpha-galactosidase in the case of soybean and related feed ingredients. But I wanted, well, to take the opportunity to show that the presence of Shillans is quite broad in most of feed ingredients. But then if we go to beta-glucans and mannans, which are also object of other enzymes like beta-glucanase or mannanase, well, the reality is that most of feed ingredients have very residual levels of these carbohydrates, okay? As you can see here, the level is quite low. Well, we find it at a higher level at wheat bran. Here, I'm not showing barley, which is not a main feed ingredient in your area. In Europe, for instance, barley, it's more used, not that much anymore, but it's more used. And in barley, obviously, beta-glucans are high, but in most of other feed ingredients, it's not. And we go to mannans, we find a similar situation where the levels of mannans are quite low in most of feed ingredients. So when we say that we need an enzyme targeting a specific molecule in the feed ingredient, well, we have to take into account this fact. It also happens with phytase. Obviously, phytase is focused to degrade phytates. And that's why nowadays we are using phytase in all the diets. We do not conceive using diets in most of situations without phytase. But we have an enzyme focusing on a specific target that eventually gives a performance, a result in the performance in the animal and in the reduction of inclusion of phosphorus in the diet, in the case of phytase. Next slide, please. Okay, Capsozyme S plus, SB plus is a combination of galactosidase and chilenase. Indeed, the real value of this enzyme and the technological development that we have done at ITPSA for more than 25 years is this alpha-galactosidase, which makes the difference in the profitability of soybean and other legumes. Okay, so it allows to maximize the digestibility of soybean. We have two enzyme activities. As I've said, the main enzyme activity is alpha-galactosidase. In our product, we also include a beta-chilenase, an endo-beta-chilenase, okay? Mostly because with this product, it can be adapted to any kind of diet. So the more classical diet with corn, soybean meal mostly will require galactosidase, and that's why this is the main focus of the product. But then also in other areas, in other regions, like for instance, as I say, in Europe, the presence of wheat in diets, rye, etc., it also justifies in some occasions the use of beta-chilenase. So we have a combined product, okay? Alpha-galactosidase, degrading galactosides, I have mentioned, for soybean and legumes, arabinochilans in the case of corn and wheat. So eventually releasing sugars, improving the gut comfort, the gastrointestinal comfort, and also having an impact in the brush border activity of these sucrase this sucrase, this invertase that I was mentioning, it's the same enzyme. Okay, so eventually releasing more nutrients for the animal. I mentioned here the reduction of gas production and improving the gut health. The reduction of gas production is critical in the case of alpha galactosides. One of the main detrimental effects is the production of gas by microbes in the gut, and this gas is impairing the proper functioning of the gut, as I will show. Next slide, please. Okay, I also wanted to go a bit deeper in these differences between the different feed ingredients. Here I'm showing results, data from literature on very simple analysis of the sugars that are present in the different feed ingredients, the profile. So you have the carbohydrates, you completely hydrolyze them, and you quantify the level of the different sugars. So arabinose, xylose, mannose, galactose, glucose, etc. So you can understand which are the main carbohydrates present in the different feed ingredients, okay, in a simple way. So here we can see, if we focus on xylose, that would, if you have high levels of xylose, it means obviously that you have high levels of arabinoxylose. Well, it's obvious we have high levels in corn, in wheat, in rye, in barley, but you can see that we have significant levels in soybean, rapeseed, okay? If we go to peas, fava beans, etc., cottonseed, different alternative feed materials for soybean, we also see that the levels of xenose and arabinose, so arabinoxylans, is quite high. So it's something to be taken into account. So in these cases, it makes sense to consider the use of chilanase, okay? But most importantly, next slide, please. Now, the previous one, I think you missed the previous one. Okay. Yes. If we go to the beta-glucan and mannose, we see that, yeah, as I mentioned, indeed, the levels are really high in the case of barley, as you can see here in the green bar. But if you go to other feed ingredients, it's not high. So we have it high in wheat, in rye, in barley, but then some other feed ingredients like corn, like soybean meal, rapeseed meal, and other protein sources, the levels are very low, and it's similar to mannose. So you have to properly check your diets in order to assess if the use of specific enzymes for very specific carbohydrates are making a difference in your diet. So in many of the diets we evaluate, and we are being evaluating, and we test, well, the target molecule is at very low level, so the advantage of using certain enzymes is also low. Next slide, please. And now I wanted to mention what we find when we evaluate galactose. Galactose, which means if we find high levels of galactose, it means you will have there high levels of alpha galactosides. And as you can see, well, the levels of galactose for soybean meal are high, are very significant. You can find them there in rapeseed meal also, okay? Even corn have some levels of galactose. And there are some other feed ingredients like white lupins with very, very high levels of galactose, and also present in other feed ingredients. So that's why we are justifying the use of alpha galactosides, okay? Next slide, please. This is a summary of I have been mentioning in the previous slides in the figures. So beta glucans are relevant only in barley. So the use of beta glucanase, it would be justified if you are using barley. Otherwise, you should properly evaluate if it's making a difference for your diet. In the case of mannans, also they are low in most of raw materials. So you also have to evaluate the advantage of using manganese depending on your feed ingredients. In the case of alpha galactosides, we've seen that they are high in soybean meal, cottonseed meal, rapeseed, sunflower meals. Okay, so most of legumes have really high levels of alpha galactosides, and also we've seen that arabinoxylans are mostly everywhere. We have it in corn, in wheat bran, but we also have it at certain relevant levels in cottonseed, sunflower, and also in soybean, rapeseed. So, well, it's also interesting to bear in mind these arabinoxylans, and that's why we developed quite a few years ago already this Capsozyme SV Plus, mostly focused on alpha galactosides, which make the difference, and more especially in corn, soybean diets, but also, well, these arabinoxylans that can be present everywhere makes the Capsozyme SP Plus a very flexible tool for many kind of diet formulations. Next slide, please. Okay, here I'm just showing briefly what I've mentioned about the levels of alpha galactosides in soybean. Here I'm showing three origins. This is from a study with a number of samples from different origins that was published. And as you can see, there are certain differences which are important, but in the end, you can see that the levels of sucrose, the levels of raffinose, and the levels of stachyls are really high. So in these samples from these different origins, we have percentages, overall percentages, which are from 13 to 15% of overall, okay? So the presence is really relevant. Okay, next slide, please. Okay. I was mentioning about alpha galactosides as anti-nutritional factors. We know that they are non-digestible oligosaccharides, as I have mentioned. So the detrimental effect is because they are fermented. They are fermented by certain parts of the microbiota. And they produce gas, and this gas produces flatulence. This is important. You know also that this happens in human nutrition when we consume legumes, that we may suffer this kind of discomfort, and this happens with animals. So it happens an intestinal discomfort, which has an impact globally in the digestion of all nutrients in the diet. We may have also subclinical bowel inflammation. This results in the end in an increase of the intestinal passage rate, so a lower digestion of absorption of nutrients. That's why the presence of galactosides, as we will see later, has an impact to the absorption of all nutrients related to energy and protein, okay? Because it's not only degrading galactosides and taking advantage of the sugars of these galactosides hydrolyzed. It's about the impact of not producing this gas and not impacting the functioning of the gut. And also, eventually also, this malfunctioning of the animal intestine produces an imbalance of pathogenic bacteria, and this has an impact. We have seen this in studies in a poor barrier function, okay, and also an increase of immune stimulation, which also poses an energy waste that we cannot perceive from a pathological point of view, but in the end, in the performance, we see it, okay? So what we have seen throughout the years is alpha-galactoside may represent up to 15% of digestible energy, okay, and 10% of protein in this soybean ingredient. Next slide, please. Well, I'm showing now a result. This is from the 90s. So we know about this the effect of galactosides for a long time, even if industry has not been focusing on this apparently. I'm showing here results of a study where they tested diet in poultry, in chicken, with soy protein concentrate with respect to this soy protein concentrate without the galactoside, where these galactosides were added on purpose. Okay, so to see what is the effect. We have the control, and we have the same diet adding raffinose and stachyose. And as you can see, there's a reduction greater than 10% in the true metabolizable energy, and also of 20% of dry matter. So it's really, really relevant. Next slide, please. Now I will show some results on how specifically Capsozyme SV Plus allows us to improve the metabolizable energy utilization and also nitrogen retention, that is the digestibility of protein in poultry. Next slide, please. Here I'm showing results. These are results from ITPSA. This study was performed at ITPSA, which is a renowned research center in Spain. Well, here we tested a corn-soybean diet for chickens, a classical corn-soybean diet with about 30% of soybean inclusion. And we can see when using Capsozyme SV Plus at 350 ppm, we have an increase in the nitrogen retention of 8%, and in this study we found an increase of apparent metabolizable energy of 7%. So quite close to some literature studies like the one I have mentioned in the previous slide. Okay, next slide, please. Here I'm showing a study where we tested two different dosages of Capsozyme SV Plus at 350 and 500. This was added on top. So in this study, there's no matrix, there's no overvalue in one of the diets, and then we have a diet where we overvalued the diet and restricted the energy 100 kilocalories, and also a restriction of lysine. So what we can see in the results is that from the control with the digestibility of the metabolizable energy of the control, we find that when using it on top, we have a relevant increase, 76 kilocalories for the lower dosage, 120 for the higher dosage. But I wanted you to see the difference of the effect of the enzyme when you add it on top and when you use a matrix. So in both cases, they are acceptable strategies. But if you want to maximize the effect of the enzyme, it's relevant to use a matrix which is properly balanced, okay, and having a properly balanced can only be done by doing many studies. But as you can see here, by overvaluing, we found an improvement of 165 kilocalories at the lower dosage and 255 kilocalories at the higher dosage. Okay. Obviously, when we use matrices, we are not searching these levels of improvements because it depends on many factors. So we elaborate matrices which can be that you are sure that will give a profit in different commercial conditions, but at least to show how different can be the behavior when used on top or we're using a proper matrix. Next slide, please. And now, very briefly, I will show how the enzyme impacts to the digestibility, to the degradation of these anti-nutritional factors, this galactoside in poultry, and also we have data in pigs. Next slide, please. Here I'm showing very briefly, this study was done by us in collaboration with the China Agricultural University, and we evaluated in vivo in broilers, in corn, soybean diets, that the digestibility, that is the degradation indeed of raffinose and estachiose. And as you can see, the digestibility is improved at 45% and 34% for these two alpha galactosides. And in these studies, obviously, we found an impact in the performance of these animals. Next slide, please. Here I'm showing similar results in pigs because we know that pigs have the capability of dealing better with the fermentation of carbohydrates. But even in this case, you can see the difference of using alpha galactosidase with respect to the control, with an increase of 34 to 50% of galactoside. Okay. Next slide, please. And here also I'm showing, we were mentioning the impact also in gut health, which is relevant, which has in the end an impact in the performance of the animals. Here I'm showing results on the effect in Villus 8. Okay, so in increasing this Villus 8 as an indicator of gut health. And I'm also showing here viscosity, which has an impact in viscosity. We know that with our product. As I say, the gas production is key in the global effect of the enzyme, but it's also true that evaluating gas production is not that easy at the laboratory level. So viscosity can be used as a marker, and you can see also an improvement in this case. Okay, next slide, please. And now I will show some results related to the use of the enzyme on top and using the matrix that we have validated. Next slide, please. This is the matrix we generally recommend. Okay, it can be fine-tuned depending on the needs of the customer, the diet, etc. I will not go deeper in the values of this matrix because this is something that Dr. Joseph will discuss more deeply in his presentation. Okay, I'm just showing here at the moment this matrix. We have a different matrix for the low level we usually recommend, and the higher level of inclusion of Capsozyme SB+. Okay, just for you to have it, and we will discuss it in the subsequent presentation. Next slide, please. I wanted to show, as I've mentioned, that obtaining a matrix of the different of a value of nutrients by using a product, an enzyme in this case, or Capsozyme SB+, requires to do a lot of studies. I'm just showing here, just as an example, we've been doing studies for many years. As you can see, we have here studies at Autonomous University of Barcelona, at IRTA, this research center that I mentioned, which is quite renowned in Spain and in Europe, but studies in Canada, in Israel, in Thailand, in China, in many places. And what we have consistently found is that we can recommend an overvaluation of soybean meal energy and protein amino acids of 10% and 8% respectively, okay, with good performances, which even improve the performance of the control. Okay, just for you to understand that you need a lot of data in order to properly design a matrix which is really consistent in the field. Okay, next slide, please. Here I'm showing a meta-analysis of 4 trials that we performed in a research center in Germany and another research center in the Netherlands. Okay, this is different studies where the enzyme was used on top at 2 different levels, 350 and 500 ppm. And as you can see that with respect to the control, you have a clear effect, which is dose dependent in the feed conversion, in the feed to gain ratio. As you can see, there's nearly a linear effect with respect to the conversion that you obtain in the control. This was a corn, wheat, soybean diet. So there was corn, but there was also wheat in this diet. And this is source of 4 trials. So a lot of data. Next slide, please. Here I'm showing results from a collaboration with the China Agricultural University in broiler, also in a corn, soybean based diet. In this case, we have a control diet. We have the control diet adding the enzyme on top at 350 ppm, and then we have the diet with a restriction of 2% in metabolizable energy and protein and amino acids, okay, using the same enzyme dosage. As you can see in the results, well, body weight not only was not affected, but we observed an improvement with respect to the control. Obviously, in the use on top, but also in this case in the use with a restricted diet. We can see here that there's no difference indeed. So we can consider that this is the same value. So, and also in the feed conversion, we see that obviously what we expected, the feed conversion is improved when the additive, when the Capsozyme SV Plus is added on top. This is obviously what we would expect, a clear improvement of performance. But then when we have the diet restricted at 2% energy and protein, we found that the conversion is not impaired, okay? So we have no effect because of this restriction. So in this case, you have improvement of performance. In this case, you have an improvement of profitability. So different objectives. As you can see, the percentages of improvement in body weight and feed conversion on top, and the no effect because of restricting the diet in the first treatment. Okay, next slide, please. This is another study which is similar to the previous one, but in this case, instead of 2%, here we use a 4% restriction of metabolizable energy and protein. We have a control on top, and then the restricted diet with this dosage of 350, okay, similar to the previous study, but with 4% restriction. What we find here is that the results in final body weight are similar, okay? Similar results. Well, you say, okay, on top, as I found the same body weight. Yeah, but the feed conversion is clearly improved. We always find an improvement in feed conversion when used on top. So an improvement of the performance. What happens when we use this restricted diet? Well, the enzyme is able to absorb this restriction by releasing, by improving the digestibility and absorption of nutrients. So we find that feed conversion is not affected with respect to the control. Okay, here again, we have an improvement of profitability in the diet. Next slide, please. Here I'm showing a study where we where we replaced 10% of soybean meal by cottonseed. Cottonseed is a very, very challenging feed ingredient. I have shown in previous slides where the levels of galactosides and other anti-nutritional factors is really high. But at the same time, the use of these alternative ingredients gives you more difference, more improvement when using Capsozyme SV+. So it's interesting to use precisely this kind of alternative ingredients. In this case, is a study where it's added on top, okay, at a bit higher level of inclusion, 450. You can see that body weight is exactly the same. We found the same body weight of animals at the end of 42 days. But clearly, we have an improvement in feed conversion. As you can see, it's constant. What the effect when added on top, that we found a reduction in feed conversion, which is indeed what we are looking for. In this case, 6.6%. Next slide, please. And here, just for you to show how many challenging and different diets we test, and we are used to test, because obviously we market Capsozyme SV+ in a number of different markets. This diet probably is more focused in the European situation, but as you can see, the diet is completely different from the classical corn soybean diet. Here we have wheat, we have rye, and we have triticale. There's no corn, okay, so quite challenging. And obviously we have soybean meal. Even in these cases, well, when added on top, in this case, at 350 grams, we have an improvement in body weight. We have an improvement in average daily gain, which is obvious that we would found if we have an increase in body weight. The average daily feed intake is not increased. And obviously, as a result, what we find is a better conversion, okay? So the feed to gain ratio is clearly improved also in this diet, which is completely different from other diets in other regions. Okay, next slide, please. Okay, I'm showing this slide. I will not go deeper into the results, but just for you to show that obviously I have mostly focused in results in poultry, but obviously we have a number of studies with consistent results of improvement of feed conversion, or when using the matrix of absorbing the effect of reducing the levels of energy and protein in different species, in pigs, obviously, but also in aquaculture, in different collaborations with research centers in Asia and different partners. So just for you to show that, well, to have this matrix, and also to provide consistent advice to customers, you need to do the studies, and we have a number of studies in different species. Okay. Next slide, please. I'm already finishing my presentation, so just as a summary of I have been speaking in this presentation. Well, we have an increase because of the use of Capsozyme SV+, an increase in the nutritional value of the diets in terms of metabolizable energy, crude protein, specific amino acids, because we have the digestibility of the specific amino acids in our matrix that Dr. Joseph will show. We have an increase in the nutritional value of poultry feed. As a consequence, we are providing a tool to make profitable decisions on the use of soybean meal alternatives, and also of soybean meal as such in feed formulas. We can reduce the feed cost without impacting the animal performance, as we have shown. Next slide, please. Well, it favors also gastrointestinal comfort and structure, feed digestion, and nutrient absorption. I have have shown and have stressed this gas production, this degradation of these anti-nutritional factors having an impact in the functioning of the gut, and also in the microbiota and the presence of pathogen bacteria. It also reduces the threatens to the intestinal mucosa and to the gut, generally speaking. It allows also Capsozyme as to reduce the nutrients wastage, this gas production, as I have said, at the gastrointestinal tract level. Also, it allows reduce nitrogen excretion and improve energy utilization. So it also has to be mentioned that because we have to be more used to this fact that we need also tools to ensure that we have a sustainable industry, so a sustainable animal production. And in this case, it's really, really, really relevant. Indeed, in many markets, I come from Europe. In Europe, there are a lot of programs in order to improve the use of soybean, because Europe is a net importer of soybean meal. So any strategy that allows improving the use of soybean, the profitability of soybean by animals is very, 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 very demanded in Europe, but indeed in all different markets. Okay, and next slide. I think for me this is the end of the presentation. I'm showing in this slide just as an example. Also, we participated in a 4-year consortium project with many research centers, as you can see, all over Europe. We were participating here, and many of the studies and many of the research we have been doing in the last years was also performed in this important research project. You can find some results in the website of the project. Okay, and now next slide. I think now, yes, it's the end of my presentation. Thank you for your attention, and obviously at any moment I'm available for any questions you may have. Thank you.
Wow, thank you Dr. Sergi. Tepuk tangan sekali lagi untuk Dr. Sergi. What a great presentation from you. Thank you. Jadi Bapak dan Ibu sekalian, ada beberapa poin penting yang harus saya bacakan di sini, yaitu Capsozyme SP Plus merupakan enzim galaktosidase pertama di Indonesia yang sudah di-approve by Europe Commission, dan itu hanya oleh ITPSA dan distributori oleh Cita Indonesia. Tepuk tangan sekali lagi dong. Terima kasih. Capsozyme SB Plus, enzim galaktosidase pertama di Indonesia ini merupakan kombinasi dari sinergi alfa galaktosidase dengan silase yang bekerja sama dengan memecah anti nutrisi dari alfa galactoside. Nah, dan juga ini peluang bagi Bapak dan Ibu sekalian yang menggunakan pakan konsentrat maupun feed mill yang juga memproduksi konsentrat, yang mana ini akan mereduce daripada kos pakan itu sendiri. Dan pada akhirnya akan meningkatkan daripada efisiensi pakan. Seperti itu Bapak Ibu. Untuk acara selanjutnya akan ada tea break terlebih dahulu yang telah kami siapkan. Kami perbolehkan untuk Bapak dan Ibu untuk menikmati sajian yang sudah kami persiapkan di sebelah kiri panggung atau di sebelah kanan dari Bapak dan Ibu sekalian. Untuk tea break akan ada ada 15 menit dari sekarang. Terima kasih, dan juga saya informasikan untuk Bapak dan Ibu hadirin sekalian yang ingin untuk meminta dari materi narasumber pada hari ini, diperbolehkan untuk daftar memberikan nama dan juga alamat email di depan dan juga atau mungkin bisa meminta kepada sales masing-masing. Seperti itu. Terima kasih. Silahkan dinikmati. Terima kasih.
Selamat datang di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan pedagang aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia. di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan perdagangan aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast-moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia. Selamat datang di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan perdagangan aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast-moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia. Selamat datang di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan pedagang aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal dan eksternal. Kami berkomitmen sebagai tim yang bekerja sama untuk mencapai tujuan bersama. Kami akuntabel, yang berarti kami bertanggung jawab atas tindakan, perilaku, kinerja, dan keputusan kami. Misi kami adalah menyediakan produk berkualitas dan keahlian layanan untuk kehidupan masyarakat dengan cara yang menguntungkan untuk mitra kami. Misi tersebut diaplikasikan melalui komitmen jangka panjang, menyediakan produk terbaik dan layanan yang berbeda. Dalam bidang nutrisi dan kesehatan hewan, kesehatan gizi adalah tentang menemukan keseimbangan yang tepat antara memenuhi kebutuhan dan merangsang asupan dengan harga yang dapat diterima. Kami telah mengembangkan kemitraan jangka panjang dengan pemasok bahan baku, dengan tujuan memastikan bahwa kami menerima bahan-bahan berkualitas dengan biaya terbaik. Dan kami juga berfokus pada beberapa bisnis inovatif seperti perdagangan bahan baku dan sumber herbal untuk pakan. Berbagai lini bisnis Cita Indonesia diantaranya nutrisi dan kesehatan, solusi pertanian, konstruksi dan logistik, fast moving consumer good. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Cita Indonesia for a better Indonesia.
Masih kembali lagi bersama Cita Indonesia dan ITPSA. Saya persilakan kepada Bapak dan Ibu yang telah menikmati dari tea break yang telah kami sediakan untuk kembali ke tempat. Karena acara akan segera kami lanjutkan. Acara selanjutnya yaitu ada presentasi ketiga dari Dr. Joseph Mascaril, Business Development Manager ITPSA dengan topik How to Evaluate Enzyme Efficacy. Izinkan saya untuk membacakan kurikulum vitae beliau. Dr. Joseph Mascaril graduated in veterinary medicine from the Autonomous University of Barcelona and obtained his doctorate in veterinary medicine in 1994. Soon after, he joins the technical departments of ITPSA, a leading Spanish manufacturer of food and feed nutritional supplement with a great capacity for agrotechnological research. In 2005, he returned to the headquarters of Barcelona to assume responsibility for the European market, and in 2011 as technical director. In 2013, Dr. Mascaril, as a business development director, established the new ITPSA Asia headquarters in Bangkok, Thailand, and in 2019 promoted the creation of the ENCAP. Dr. Joseph Mascaril has 28 years experience in animal nutrition as a result of his work in ITPSA company. So, tanpa berlama-lama lagi, langsung saja. Please welcome Dr. Joseph Mascaril, Business Development Director, ITPSA.
Okay, now I think it's working. Well, good evening, everyone. Salamat siang. I'm sorry, I don't speak your language. I barely speak English and a little bit of Spanish. What I'm good doing is dancing. Some of my colleagues, they were asking me to dance, but I said, no, not today. Let's do it another day, because today we have to focus on what we have in mind, which is about the Capsozyme MSB. I would like the first to say that my presentation, although, well, many slides on it, I'll try to be concise and following the previous speakers, Dr. Manuk, that already gave us a clear area where the enzymes and the understanding why is, I will say that one of the most important feed additives that we have today, and it will continue going in that way. And then the specific presentation of my colleague, Dr. Carnet, where he placed the basic understanding of 22 years of evolution with our enzymes. In my case, I'm going to be working specifically in that aspect that sometimes, and you will in one moment or another, start asking how we can evaluate an enzyme, how we can really get if this that we are going to use in our diets is going to be or not effective. I think that, honestly, I have to say that is always quite complex, but we try to do an approach that allow us to apply what we are getting in a different markets and scenarios. And is this what we are getting here today? Oops, the next one, please. Well, definitely, at the end, what we want is that we can get all benefits, advantages by using raw materials, by obtaining results with these raw materials. and getting the output, which is the animal production. We are here, as my colleague Sergi said, to obtain benefit of our activity. Otherwise, why we are doing things, you know. But of course, definitely with an only on this making money business, but also to nowadays being proactive and helping to improve the environment and to make sure that the utilization of that expensive raw materials will be highly used by our animals, and so getting the benefit that we're expecting. By doing that, we are going to do, using feed additives, and specifically those that will give us an advantage. There are many types of feed additives, but we have those that allows you to maintain, preserve the shelf life of our feeds or raw materials as fresh as possible. But then we have those that we are using in animal nutrition to improve the utilization. As we saw, the raw materials, all of them, soya in particular, are very good, but even with that goodness that they have, they hide something that sometimes is not giving us the best output, which is these anti-nutritional factors that we may have problems. So, as Dr. Carne mentioned before, we have here a kind of bad guy, which is the alpha-galactosides. The alpha-galactosides in soya, as he was describing, they are not NSP components. We already been classified as a non-absorbable sugars, because these are quite simple sugars, but really not usable by humans, but neither by animals, either dogs, pigs, poultry, or fish. And that is one of the reasons why, even here in Asian cultures, soya, tofu, that we all know, have to be treated in order to reduce this type of fermentation. So that is one thing that forced us at the beginning to consider why we cannot get this improvement of the very good raw materials, but that they have this anti-nutritional factor on there. And that was start our interest on the alpha-galactosides. The alpha-galactosides, this is the pathway, how the enzyme work, how this molecule that we consider not good can be or will be hydrolyzed. I have to say that, as you well know, alpha-galactosidase enzyme per se is not a well-known enzyme. As I said, we've been working for a long time, but still not being one of the most famous enzymes. What is that for? Well, what it is the complexity of this process. Not because its enzyme is very complex, but because to obtain results, to evaluate the efficacy of this enzyme became quite complex and more with our diets. As you know, a diet is put together different raw materials, all of them with different characteristics, and to obtain a good information out of that always make complication. And this is the base that I will try to show today, how we try to evaluate enzymes, and specifically the alpha-galactosidase. Well, in this pathway here, we can see in the first area something like raffinose, which is the well-known alpha-galactoside, not the most difficult one, but it's the well-known, with 3 molecules, 1 glucose, so we can see here, 1 fructose, 1 glucose, and 1 galactose. We want to hydrolyze them all. When in monosaccharide form, we can absorb it. All animals can absorb it. They provide energy, and they also can be used to create other molecules and structures. But that doesn't happen unless you have the enzymes developed. And in this case, the most important, the most relevant, and the necessary enzyme to be present is the alpha-galactosidase. Alpha-galactosidase break down this bonding between the galactose and the glucose, and by that simple thing, there is no fermentation. Fermentation that we already said, my colleague was informing that they produce gas, they reduce the store absorption, and in humans, produce as well flatulences. We all know what happens when we eat beans. We cannot be in the room at that time. But the thing is, we've been working in that part, and we also been researching, and nowadays we believe, and the registration in Europe, which, by the way, is not always easy, and I would say it's always difficult, we obtain this commercial product able to be used in any source of legumes, and particularly soya. And with that, we maximize the nutrients that we will have in our diet, because it's not just obtaining the sugar-free, but also reducing the effect, this fermentation that we will take or will reduce the absorption of many other nutrients that we are also placing in our diets. Well, how we do that? Well, Sergi already showed you trials showing that during many years we've been evaluating, putting on top, searching what is the benefit. But nowadays, with all this experience behind, we are working with the conceptualization of how we can help, how we can introduce the use of the enzyme in a practical way. We all ask, well, okay, I have the enzyme here, but how should I use it? And I would say that the evaluation of the enzyme, not only the activity, the stability, but also how we can introduce it in our diets, it becomes even more important. That is also been one of the, the reasons why a few years ago we established our own lab, and in that lab we do services. We also help our customers for this control, evaluation, efficacy, in order to obtain, well, the answer and clarify better how the enzymes, and particularly Capsozyme B, it works. But what we can have here is that you need to obtain information, reliable information. And when we go to that, when we want to work with that, we need to get this information by doing trials. Trials that can be, in many cases, run by universities or research centers, but also could be run in your farms, as long as the purpose, the objective, the design of the lab, of the trial, allows you to obtain clear information. And that is what is important. So we have several methodologies. We can put it here as a direct determination or indirect determination, which is, I would say, that is more clear than just the description. When we analyze how much fat or protein is being absorbed by the animal, how much energy we obtain when we add, in this case, enzymes, but it could be other feed additives. That is a direct evaluation of how you, what is the benefit, specific benefit that you obtain by adding a feed additive. Or we have an indirect evaluation. This one is, I would say, this the easy way, is that most of us are aware and familiar. You just put it in your diet, you see your animals, and if they grow, okay, and if they don't grow, doesn't work. Well, this simplicity, sorry for putting that way, sometimes give information. But what is more important is everything that surrounds that part. And when I say everything, and let's say focus on our product, is conditions of your lab, your farm, your place that you are going to run it. Conditions that not only if it's well distributed, well located, but also the feed. Your diet is definitely the most important variation factor that you will have. Not only because you use different raw materials, because even if you use the same raw materials, we know that if you use soya from what we showed before, Argentina, or from India, or from America, it's not going to be, well, all are called soya, all could be called 47% crude protein, but not even the one that you bought from the same origin last year or last month could be the same one. So that's why actually each time that you perform a trial, each time is different. Each time is different. And I repeat again, each time is different. And so you need to make sure that when you run that trial, the conditions of anything that you want to evaluate have the same one. And how you make that? Well, also it's difficult, but you could have that all, let's say in this case, if you evaluate an enzyme or several enzymes, all are placed in the same conditions, all with the same diet, all with the same variation. And then the diet factor disappear, and you get easy way to evaluate the efficacy, the efficiency, or the activity of, let's say, enzymes here, but it could be any other thing. Sorry, I wanted to say that specifically with Capsozyme B, what we work is definitely what we call the diet nutrient density. Well, this is a scientific term, so simple. How much energy, protein, and amino acids you decide. Your nutritionist say, I want 1.1% lysine or 1.3. Who make that difference? You decide which lysine content, because your experience, your knowledge, etc. So that thing, it will be a variation, as well as the energy, fat, or fiber content. So what is clear is that makes a big change. And why it makes a big change? Because all of them interfere on nutrient absorption, nutrient utilization. And when we want to evaluate whatever feed additive, that should be known and controlled. You can change it, but you have to know how it's being changed. And then we have another part that always is what is the ingredients, the diet, but and also those elements that are hidden. And specifically in our case, as we said, the alpha-galactosides. Alpha-galactosides content, although there is a lot of literature, we are also working in order to evaluate, to analyze them. Not always easy. We can analyze them, but you are not going to be doing this analysis every day, and makes complex, but at least you need to have an idea why or how much you're going to have them. The amount of alpha-galactosides is not just the percentage that contain the soya, but also how much soya or any other legume are you adding, okay? So this percentage of inclusion of ingredients may also interfere in that part. So that's what we are trying to work with. Well, now I will show you one of the recent trials. This was performed in India. I think that all the things that I will show today is India trials. Why India trials? Well, because as in here, we are also working in there. We have in China, we have in Vietnam, we have not yet in Indonesia, that I hope be able to work. But doesn't matter, as I said, location. What it matters is control the parameters that you are working with. And in that case, here you can see that what we designed is a trial where they have a control group of diets, which in this case is showing that was a direct determination, because we evaluate the apparent ileal digestibility. As Dr. Manuk said, we need to have absorption in that area where the absorption of nutrients is beneficial. Anything that is going to be absorbed in the column or the last part of the track, that will only benefit microorganisms. That of course we need good microorganisms, but as you are putting lysine, you want that that lysine will be absorbed and will be utilized by the animal to grow, not to have more bacteria, and which, well, if you want to do that, you need to be feeding probably ruminants, which they will modify, and then we get that thing afterwards. But the thing is, this trial in pellet form, we have this a corn soya-based diet. We can see here that we define two levels. One is regular level, a diet conceived with no standard decision of the nutritionist, and then we lower 3% of metabolic energy, 6% of amino acid content for this digestibility trial. Well, what we can see here is for you to see what is the diet per se, the composition. As I said, what we call REA, which means regular energy and amino acid content. These two diets are equal, and the low energy and amino acid content, again, all equal. Among them, there is no difference, but when you compare one group and another, for sure is difference. But here in the same trial, we can evaluate and obtain information. This was 100 kilocalories reduction and amino acids as well. That is one of the surprising things that we saw. Of course, we were expecting, but the thing is, the orange line is showing what we thought we were doing in formulation. We designed a diet, 3,150 kilocalories, and another group of diet, only 100 kilocalories less. It was formulated with 3,050 kilocalories. But that is what happened. I mean, how many of us analyze soya or any of your raw materials in terms of energy content every time that you have a raw material? I would say that very few. Most of us, we are using the metabolic energy values from tables and from experience. So at the end, in that research farm, what we were doing here, we can see that the control diet, which is the one showing 2,916, was below what we were expecting. This is what the animals, this is digestibility value. This is what the animals were obtaining. Sergi already said to us that the crew energy, the gross energy, and the real energy in diets is not always what we're expecting. But definitely this is what happens in some areas, more or less, depending on quality of the raw material. But this is what happened. And then if we compare with the low energy and amino acids, which is 2,720, we only reduce 100 kilocalories. But here we get almost 200 kilocalories. So that is what the animal experienced. That's the real restriction that we had. And then when we put the enzyme, well, here, what we can see is that only enzyme effect in each group. Among them, there is difference of energy and protein. But inside of all the each group, the enzyme, with any condition, is able to increase, in this case, the digestibility of metabolic energy. And it's, Sergi already showed you the results. Let me put it also here. That is where it comes from. So density of nutrients determine effect of the enzymes, because that means you have more digestible nutrients. But if you are using a poorer raw material, restricted kind of raw material, the enzymes, and that is what you are looking for. With the same enzyme, the same dosage, you get better results. Well, that is one of the things when I am being asked about, well, what is the matrix of your enzyme? Well, my matrix, and I think that is the tendency today, there is no one matrix value. The matrix, we tend to say that we can adapt it to the conditions, depending on how good is your diet, because we always think that our diet is the best one. But maybe our decision is not to have high density diet. We may be working with a lower density diet because nowadays it's expensive raw materials. I have better benefit by not using the most expensive one and using the cheapest one. Of course, it will take me longer probably for production, but it's something, that is not any longer the nutritionist managing these things. With these tools of feed additives, like in this case, Capsozyme B, you could have this advantage. So why adding on top? You can use it, the product. In this case, although by concept is on top application, none of them is on top application. Because as we saw before, this energy that we were expecting was not there, And that is one of the things that we have to have in mind. Well, this is the indirect determination. In this one, we only measure growth. You know that growth is not the best indicator of the efficacy of anything. As again, it depends on the ingredients that you are using. You change an ingredient and you think that that was the ingredient that caused this thing, and growth is affected by many, many, many different parameters. But again, as long as you can keep clarifying and clean the variation, you can have more, the benefit of what you are testing, in this case, the enzyme, in a clear way. In this case, we did it even more extremely. That was quite extremely trial. In this case, is 100% regular nutrient content, the one that they decide in that moment. The low energy and protein content in this case was 75 kilocalories, 1% of crude protein, and 1.5% reduction on lysine. And then we also put one very low level, which will reduce 140 kilocalories of the metabolic energy in the diet, 1.2% crude protein, and 7.6% lysine. I have to say, and I suppose that you have experience in that part, when you combine energy and protein reduction, anything could happen. The animal, and broilers particularly, they are really determined. The consumption and the effect could be quite clear. But as I said, here all are the same conditions, two different groups. Well, here I'm showing two parameters, growth and feed conversion. But definitely, we can see that very low diets are really affected. But in terms of decisions, we will see later on, we may have a possibility to work with these diets because, well, we are just considering that is 100 grams different, okay? In terms of cost, it's a huge difference. But what is the advantage? The advantage is using an enzyme that will be able to compensate. How we can see the parameter that gives us more clarification is the feed conversion. We can see that feed conversion efficiency of how that animal used the same diet. The yellow bars means among them the same diet regular one, the orange among them the same diet regular one, and the pink the same diets. So we can see that adding the enzyme increase the efficiency, reducing the feed conversion, which this, again, is a direct way to weigh. It's not the most clarifying or most informative as the other one, but it's a good way to go. We put in a regression curves in order to show that there are three different clear population, which is the no enzyme, 250 grams or 300 grams of enzyme, each one of them with or without this energy and protein reduction. And what we can show is those diets, I mean, the gray color below the blue one is telling you that, as you can see, better performance of those animals, significantly better performance. And that is, I can say clear, that is just because the enzyme application, because I have the same conditions in each of the part. And that is what it is to evaluate efficacy in that way. I'm going to put some numbers because I always ask, well, do we have any benefit? Well, this is what we call on top, the regular diet, putting the enzyme on top, which particularly in my case, as I said before, this is not the best or the wiser way to do, unless you know that your diet is really low. Because if you spend money, if your nutritionist really take care, put the amino acids, the protein requirements, well, that diet is not going to be needing much of help, okay? So the benefits that you could have, of course there will be, and particularly with Capsozyme SV, soya without the alpha-galactosidase will not be able to perform their maximum, but it's not the best condition. But you can see here that already, I mean, this is showing cost of feed, cost of how much the feed, the growth of the animal cost, and then the benefit, the net profit that you obtain. So definitely, against control, the use of the enzyme, it helps. But the same condition here is compare the regular diet with no enzyme, the one that have all nutrients, when we put it with comparison with the low energy and protein. If you remember, 75% kilocalories and 1% of full protein. Well, in this case, the benefits are even better. Of course, why that is so? Because this diet, when you reduce the energy and protein, you already reduce the cost. But if we reduce the cost with no net behind that, any support in order to guarantee that I'm reducing the nutrient density, but let's see what happens, that is a very risk. Enzymes, and when you can evaluate them and have confidence, it will be able to guarantee that what you can see here, the feed conversion improve and maintain the weight of the animal, which is definitely. Well, this is the very low energy and protein. Sometimes they say, Joseph, don't show this, because why we have to show it? Well, no, because as I said, the decision of using a low density diet, let's say less digestible, less quality diet, is a decision that sometimes pay. Look at here, you reduce the cost a lot. The high risk of these things is that you need to use something to guarantee that doesn't happen. So that's why by using the enzyme, you get a coverage, a protection, an insurance. And that is how is, of course, I would say, I better don't go to the 140 kilocalories with 75 or in between. That is a decision why we make these trials and we create the matrices that I will show you later on. How we do these approaches? Well, at the end, you will ask me for a number. How should I do it? Well, there is several strategies. As I said, on-top application is quite common. But then we have also, as Sergi mentioned, the possibility to work with modifying the energy content or the protein content of the soya, which is the matrix of the soya per se. And there is another possibility is working with the matrix of the enzyme. This, I think that we are all used to phytases or other enzymes that they have this matrix on it, and this is a good way to be working with. But what is important, and is what I try to show, is that those matrices have to be really challenged, really obtained, and that's what we are going with these values. And we can also have the diet matrix. Diet matrix is the one that I apply in the test, which all the diet, whatever it is, I reduce the energy and the protein in this condition. That is another approach, but is, let's say, less advantages. From my point of view, today, if you are working with a good enzyme matrix, you have better chances to optimize cost, and that, I think that is one of the things to go. Always the expectation is that when I apply the enzyme, I will still be able to show or to observe better improvement on feed efficiency and of course feed costs, which, well, that is always depending on what is the extreme that you are getting. But it is that what you have. Well, that complexity of, I'm not going to go here, just for you to see how we establish the relation. Soya in our enzyme is the key, soya or legumes. So percentage of soya in the diet, it will be one factor that will determine. I'm showing 10% as a minimum. Of course, it could be 5%, but I would say no soya in diet, no alpha-galactosides, unless no soya in diet means a lot of rapeseed or a lot of cottonseed. In that case, it is. But soya is our key element to be alpha-galactosides in the diet. We relate percentage with energy that you can obtain, and the blue bars is showing the potential. As I show you, it's within those numbers that I have, but I never go to 240. I never go to 40 kilocalories neither. So the grade is showing the dosaging that we are working. I would say that we try 1,000 ppm and 2,000 ppm because registration requires that it's not toxicity when you add it. You have benefit, but I would say usually 500 grams of our enzyme is more than enough to work in any level of soya that you will be working. And we also register the minimum application. I would say that 350, 250 should be, depending on diets, more than enough. And one other aspect that I want to mention is the crude protein. As you recall, I've been mentioning that crude protein is part of our evaluation curve. You say, but why alpha-galactosidase? It works on sugars, and you can have protein. As you recall as well, we said that there is fermentation. Fermentation interferes fat, protein, and sugars. And all of them provide energy. There is nothing from energy alone. Energy is obtained by the metabolization of all these nutrients. So you have energy because you digest better. Of course, alpha-galactosidase digest or hydrolyze glucose, fructose, and galactose, but also reduce fermentation. And then you get all these possibilities. So protein is a factor, and protein is an element to be considered in our matrix as well. Well, this is the matrix that show, many questions could be here. This is not even the, I would say that the best one, but it's the one that we feel quite comfortable. I've been working with this in any condition, which someday we'll need to discuss how many matrix in my diet I can use, because I have proteases, I have chilanases, I have phytases, and now alpha-galactosidases. Well, I think that this is another topic and another subject in the future. But what is important is that all of those enzymes, you need to get confidence, feedback, and information. And first of all, knowing that you really have the enzyme. So analysis of this, which is crucial. Well, we can see in this case, that means our standard is 84 kilocalories per kilo minimum, and approximately when it's added to 350 grams, and when 500 grams, 120 kilocalories per kilo. You will say, too much, too little? Well, let's do a trial in good conditions, and then we will see the benefits on this. The Capsozyme SB although I have to say that we are a newcomer here in Indonesia, newcomer that already been 10 years with a company. My colleague Yen Yen, that I've been working a long time with her, I think that can also reinforce that part. I think that the thing is, we keep going in that sense, and the experience that we were getting will be, coming from all the different areas that we are applying the enzyme, not just in Asia, but also in other areas. And that is one of the helps, because at the end, the animals are pretty similar. The raw materials are not that different. And us, we look for the same objective, so which is the cause of this thing. I just wanted to introduce here kind of a also aspect for phytase that we are also working. I would say that, well, phytases, in terms of evaluation, we always go with the analytical content of the units, which is something that always require a standard methodology. As you know, probably phytase is the only enzyme that have one ISO method. So we all have to provide that composition in the same method. But even with that case, sometimes it's difficult. But the methodology, the analytical methodology of the enzyme, in vitro analysis that quantify, you have 5,000 or 10,000 units, that is not efficacy relation. The efficacy relation, again, we need to go what we start before. We need to be able to perform trials. And you will say, but that is not easy. It's true. But if you want to be, you are going to spend a lot of money with feed additives to get benefit. If you do not know if that is benefit, or you are getting a benefit with that thing, you're wasting your money. And of course, you could say, but I work with the most well-known company. That is an option. But even in that consideration, we all, and that is one of the things, we all have to have our products in your conditions, in your situation. It's not the same buying a product in Europe, a feed additive particularly, than working the product here. Temperature, transportation, everything. And again, we are in this business. And so that's why we establish a lab nearby here, because things changes. And that is something, well, it's an option. And we need to have this. Well, phytase, I will not go. You all know, we get remove of this phytic acid that chelates and produce, losses of phosphorus, and in Europe particularly, but every time here is also the environment is going to be affected. So we need to be working with this. One of the aspects that I like to mention is that phytase is not only the one that you are adding. Many raw materials contain phytases. And actually, if you analyze them, it will be present. And that is one of the key things that we have to know, because that could be a trick. Okay, there are raw materials with more, and here we may have some information. The other aspect is the methodology of the analysis. Nowadays, AOAC is the standard one, which is where everyone has to do the analysis by that. But each of us, we may have our own stabilities. Well, that's aspects that we need to reinforce. Well, these are analyses. The enzymes always need to be evaluated, and we need to have clear what we are buying, the shelf life of the enzyme, the critical stability, and that is something that we really need to be working with. The ISO method. If somebody says, no, I have my own method in phytase, everybody have the one, but we all have to register our products with the ISO method. Okay, so 10,000 units on a label are the same that another company that have in the same label 10,000 units. Same 5,000 or whatever percentage you are working with. Well, this is what I was mentioning before, that there are raw materials that contain phytase. Phytase, the enzyme that we are putting in the diet, they contain. What happens is that these raw materials, as soon as you treat them in temperature, disappear. Is, let's say, not workable. But we have to have this in mind, because if we are working with non-pelleted diets, you may consider that there is inclusion of phytase, and it's not. And sometimes when we measure, we need to have. And what happens is that if you do a test pre-pelleting and post-pelleting, you may have pre-pelleting 10,000 units and then post-pelleting only 500. Why? Because in the pre-pelleting you had already raw material phytase, and you will consider, and that was not part of the enzyme that you were adding. So these things needs to be evaluated and considered. Okay, stability of the enzyme. Well, this is what I was mentioning before about treatment, temperature treatment. Origin of the enzymes. Well, I've been bombarded about what is better, a phytase or enzyme, fungi origin or bacteria. Well, that depends on the fungi and depends on bacteria. Depends on as you know, many of the today phytases, they have a bacteria gene incorporated or recombined into a fungi. Why? Well, fungi are easier to ferment, to grow, and usually these enzymes are more stable. So, well, I would say that it's not more the origin of the product relevant, but the product in sí per se. And the product per se, you can modify by coating. Coating of a feed additive, and particularly enzymes, they only have one purpose, is to preserve the units or the stability that you are claiming. That doesn't repeat. That units of stability in the label do not relate with efficacy of the label. So you could have 500 units preserved and in your feed, but the behavior of that enzyme could be different. And this is more or less in this table. I mean, not the names, that could be, but there is research showing that the same amount of units, depending on the enzyme that you are working. Of course, we tend to work with 500 units or 1,000 units or 2,000 units, depending on if you consider the superdosing. But even when we are working with the same one, we can see here that the reference or the efficacy that the enzyme have, this is not measurable with an in vitro test of the content in your raw material. This is always, and that's why the registration in Europe goes with that, with the absorption, the ash content in bone by the animal. So again, there is an aspect that normally is not being shown, definitely is not being compared, but is the one that determine the utilization. But I would like to place here that phytases are very useful. Phytases are very needed. Of course, you never put a phytase on top of a diet because that lose all the purpose. Phytases have to be formulated by reducing, limiting the incorporation of inorganic phosphorus. Because otherwise, if you keep providing that, the animal will use, and even the enzyme is working, you are not going to have the benefit, which the benefit is reducing the environmental cost and also reducing the quantity of raw materials, which nowadays are quite expensive in that sense. Well, this is kind of a, let me be marketing. Again, you don't have to trust me. As I said, we need to be working, doing trials in your own conditions. But one of the most important things is that when you compare enzymes, you need to be able to evaluate the absorption. And that will go at the end in the matrix. So we all have these possibilities. And by doing this, as I said, you reduce the usage of certain raw materials and the cost of the diet, it goes, you know. We can also talk about the matrix of phytase. We all know that it contains protein, energy, and calcium and protein, calcium and phosphorus utilization. Well, why we do that? I would say because when you have limitation of phosphorus, the animal cannot grow. So if it doesn't set up bone, there will not be muscle being created. So when you provide the potential, the genetical potential of that animal to create bone, you allow also that if you provide protein and nutrients, they will be growing. You know, that one of the characteristics of the evaluation of this is measure how much the animal ash of phosphorus has in their bones. And that's why by using a phytase, you can also consider that energy and protein is being provided, because the animal will grow. And when you grow, there is protein and is energy. So that's simple, but not necessarily related with the reality. Well, those, again, general concepts that phytase is needed. Use the one that provides you more confidence. Analyze the content of the product. This is important. And then, as well, one of the main reasons, and I said it at the beginning, enzymes probably are one of the best feed additives so far appear, because there is not only one enzyme. It's not like when we talk about certain amino acids that you specifically talk about lysine, but in this case, they give a high potential. I remember when I was studying that we all thought that, well, if you provide all the enzymes, you can digest anything you want. That is the theory. But still a long way to go to obtain that thing. Well, I think that that's everything for today. Terima kasih. Thank you very much.
Thank you, Dr. Joseph. Please stay here because we have a new session, question and answer. Dan saya persilahkan kepada Bapak Nanung, dan juga untuk moderator saya persilahkan kepada Ibu Yen selaku Direktur dari ITPSA Indonesia. Untuk sesi berikut, yaitu adalah sesi question and answer. Jadi bagi para hadirin sekalian, Bapak dan Ibu yang ingin memberikan pertanyaannya, boleh langsung saja. Kita buka untuk 3 penanya di sore hari ini. Monggo.
Untuk pertanyaan, silakan bisa disampaikan dalam bahasa Inggris atau dalam bahasa Indonesia. Kalau dalam bahasa Indonesia saya coba nanti untuk menyampaikan ke Joseph. Silakan, mau disampaikan untuk Joseph, untuk Sergi Karne atau Pak Nanung, silakan. 3 pertanyaan pertama, dipersilahkan.
Selamat sore. Perkenalkan, nama saya Ida dari Sria. Pertanyaan pertama untuk Bapak Nanung ya. Tadi Bapak kan menyampaikan di slide di awal itu bahwa enzim itu diproduksi dari beberapa mikrob ya Pak, seperti bakteri, yeast, kapang. Menurut Bapak, sumber dari mana sih Pak yang paling efektif buat ayam ya Pak, buat broiler? Apakah dari bakteri, dari yeast, atau dari kapang? Lanjut aja. Boleh lebih dari 1 pertanyaan ya Bu?
Silakan Mbak. Silakan Mbak.
Iya, selanjutnya saya mau nanya ke Dr. Joseph. My question is, what is the source of the Capsozyme SB+? I mean, what microbes the source of this enzyme?
You mean the
The
microbe?
origin.
The microbe origin?
Yeah, the microbe origin from this enzyme. And the next question to Mr. Joseph too, Dr. Joseph. In the data of trial that you present before, was there any enzyme adding in feed trial besides the Capsozyme? Was there any
Did
enzyme?
any enzyme,
Ah.
addition any enzyme on the trial or only
Be-
Capsozyme?
Yes, besides the Capsozyme. And about the combine, I mean, how if the Capsozyme SB plus combined with the phytase? I mean, did ITPSA? Is there any matrix for the combination of the enzyme?
With phytase?
Yes,
With
with phytase or any enzyme.
Any enzyme?
Yes, like maybe NSP
Any
enzyme.
specific enzyme?
Maybe a phytase enzyme. Thank you.
Ibu Ida ya?
Ya,
Ibu Ida. Oke, Pak Nanung dipersilakan.
Oke, terima kasih. Bapak Ibu, kita ingat bahwa enzim itu diproduksi satu oleh organ di dalam tubuh. Yang kedua, enzim itu diproduksi oleh mikroba di dalam saluran pencernaan. Nah, maka ketika kita berpikir dari mana atau mana yang paling bagus, maka tentunya mikroba yang dipakai untuk memproduksi yang paling bagus adalah yang original berasal dari saluran pencernaan. Nah, maka kemudian diambil dari dalam tubuhnya, kemudian dikembangbiakkan, kemudian dipakai untuk menghasilkan enzymes. Nah, sekarang memang sudah ada microbial enzymes di mana berbagai macam enzim itu dihasilkan di luar tubuh oleh mikroba. Nah, kalau ditanya mana yang paling bagus, apakah bakteri atau jamur atau kapang, ya tergantung enzimnya begitu. Itu bisa beda-beda.
Jadi tergantung dari bahwa mikroba itu menghasilkan enzim dan punya spesifikasi tertentu ya Pak. Dia
Betul. Yang paling gampang kita pikirkan seperti ruminansia. Ruminansia itu bisa memakan hijauan dalam jumlah banyak karena memang di dalam rumennya itu kan banyak mikroba yang menghasilkan enzim-enzim selulase, hemselulase dan seterusnya. Nah, mirip dengan itu di unggas juga demikian. Unggas kan punya rumen dalam tanda kutip yang namanya sekem. Di dalam sekem itu kan berkoloni mikroba yang sangat banyak, tetapi banyaknya ya cuma segini kan. Nah, maka kemudian mikroba yang ada di sekum tadi diambil, kemudian dikembangbiakkan untuk menghasilkan enzim di luar tubuh hewan. Nah, sekali lagi, mikroba apa yang paling cocok atau paling banyak, ya tentunya yang paling sesuai di dalam saluran pencernaannya. Jadi tiap enzim bisa beda-beda.
udah cukup Mbak? Bu Ida, udah cukup? Oke. Let's continue with Joseph. The question about what kind of the microbe to produce the
This
alpha galactoside.
our microorganisms are fungi.
Why use the fungi?
As I said, nowadays fungi enzymes are more stable. Fungi are able to, and what is one of the reasons our enzymes do not need coating. They are more thermostable. So that is one of the main reasons. Also, because they are the one that producing more alpha galactosidase. There is no alpha galactosidase. At the end, you need to decide because of the output of the microorganism, sorry, of the enzyme that you want to get. So definitely we have different microorganisms for one enzyme or the other. And at the end, fungi, so far, I will say that in the market, the fungi are the one most usually used. Yeah. The stability, we've been, I mean, I will never recommend to use Capsozyme SB in extrusion, expansion or extrusion process, which in aquaculture it could happen. But we've been doing tests, and the test that we are working shows a high stability over 100, 110 degrees for 30 seconds or 1 minute. And you get, because you have destruction, you get in between 70, 75% stability, which at that temperature is quite good. And I have to emphasize that when you are pelleting at your feed, the temperature is on external part. Internally, when you mix the product, feed additives, all feed additives will be suffering that thing. They get less connection. When we try the thermal stability, we put directly the enzyme in contact with, in an oven, in contact with the temperature, which is more drastically. So that's why, but I would say, pelleting conditions, there is no problem at all. Even workhouse conditions, which is something that you cannot even imagine. 40 degrees, it does have a big impact on stability of any feed additive, but particularly with enzymes. So we've been doing experience, and we have 2 years stability with that, although we only recommend one, because you don't need to storage product when we can provide fresh every time. Then
Then the second about any enzyme additional.
I have to thank Sergi, because I always forget the names of the microorganisms, and Sergi said this: Aspergillus niger and Trichoderma longibrachiatum. Both of them registered in Europe. We need to provide the microorganisms name and stability, and so that's the thing. Then the question about
any additional enzyme on the trial?
Trials always have to be a decision of what is your objective, okay? So you can use no enzymes at all, only your enzyme, and that is only one. What happened is that we always have afterwards, but you did not use, so how we can compare? And usually, phytase is always as is a present enzyme in all conditions, and do not interfere with our protocol, is always present. I said it not interfere, although there is papers, there is literature that they try to compare phytase with other enzymes, and when they do that, they reduce calcium and phosphorus. When you do that, it's good for phytase, but it's bad for the other enzymes. So that's what I'm saying, is have to be the conditions and clear what is your objective. In one of the trials, I did not mention, the control diet, all of them, they contain chilanase and proteases, okay? You saw that they were not better. but we use it because there was the suggestion on that situation, so we had to apply it. But usually phytase is the one that you always apply. And then, well, in some way, the combination of phytase
Yes.
and as I said during my presentation, probably we need another seminar to talk about formulation, because, well, you have more experience in that sense. I am a nutritionist, but I'm not doing the formulation every day. My strategy is basically to observe what happens when you do add one thing or another. And what is clear is that if you take the matrix of all enzymes that you are using and you put in there, at the end, you will not adding any soya or any corn, because all enzymes have 1,000 kilocalories and 1,000 of, so once you use enzymes, then, as I said, the first thing is be confident with the enzyme that you're going to use, meaning that you already have the experience, that you try that enzyme alone, you see that performs, and then when you start combining enzymes, you can limit their matrix application. And then another question that probably I shouldn't answer, but what about multi-enzymes? So already together and it works. Well, the problem of multi-enzyme is you don't have the units or the activity that they claim they have. That is not possible. I mean, there is not reasonable enzyme that contain phytase, protease, chilanase, alpha-galactosidase. No. And if it does, it's on paper and cheaper. So, well, not possible.
Thank you, Joseph. Jadi intinya, apakah pitase bisa digunakan dalam formulasi bersama dengan Capsozyme SP? Ya betul, karena pitase ini sendiri tidak menginterferen Capsozyme SP. Apakah bisa digunakan dengan enzim yang lain? Dia kembalikan lagi ke kita. Apakah apa yang menjadi target kita, apa juga substrat yang kita pakai, kira-kira secara ekonomis itu apakah juga menguntungkan. Mungkin selama ini kita akan selalu misalnya dibandingkan dengan multi enzyme. Bagaimana dengan multi enzyme? Kembali lagi kita, apakah semua perlu dimasukkan ke dalam formulasi? Formulator harus menghitung apakah itu ada benefit seperti tadi, apakah ada matriknya, apa yang bisa dikurangi. Kalau misalnya itu tidak, istilahnya tidak yakin itu ada benefit, ya Pak, lebih baik dihilangkan. Cukup dengan Capsozyme SB. Apalagi kita tidak yakin bahwa apakah di situ ada substratnya, misalnya pemakaian beta glukan. Apakah di formula kita ada pakan yang mengandung beta glukan yang tinggi? Kalau yakin bahwa itu tidak ada, kenapa tidak untuk itu dicabut dan diganti dengan enzim yang jelas-jelas bahwa substratnya ada di dalam bahan baku pakan kita. The next question, penanya berikutnya. Mungkin sudah ngantuk ya. Saya harap enggak ya.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Mungkin I talk in bahasa ya.
Baik.
Pertanyaannya, pertanyaannya pertama untuk Joseph. Tadi dikatakan bahwa rata-rata ya, hampir yang saya pahami, pitase itu kan source-nya rata-rata dari E. coli kan itu. Jarang yang dari fungus kan itu. Dan memang tadi ditampilkan juga bahwa yang source from E. coli cenderung reaktif terhadap pepsin. Sehingga beberapa pitase yang diproduksi rata-rata bentuknya adalah enkapsulasi kan gitu. Nah, seandainya terjadi reaksi antara pitase yang katakanlah leaks from the encapsulation terhadap pepsinogen, itu seperti apa reaksinya? Itu pertama. Kedua, tadi kan Capsozyme
Pak, mohon diulang ya tadi yang pertanyaannya, apakah
seandainya terjadi reaksi leak ya dari enkapsulasinya itu ya, terhadap pepsin ya, tadi pepsin disebutkan, itu efeknya seperti apa gitu?
Maksudnya si kapsulnya dipecah sama pepsin, apa yang terjadi?
Ya, enkapsulasi kan tidak 100% terenkapsulasi kan Bu ya. Enzim itu kan, kadang mungkin faktor secara fisik dia akan rusak kan gitu, atau secara biologis kena misalnya kutu ya, itu juga bisa menyebabkan kerusakan terhadap enzim itu, karena faktanya juga ada di lapangan seperti itu ya, yang saya pernah tangani dan pernah saya alami kan itu. Nah, kalau seandainya terjadi seperti itu ya, enzim pitase yang tadi yang dari E. coli reaktif terhadap pepsin itu efeknya seperti apa nanti gitu. Itu pertama. Kedua, tadi kontribusinya Capsozyme rata-rata hampir semua ya, enzim itu untuk energi 80 sampai 120, bahkan ada yang 200. Tadi dihitung 240 kan bisa berkontribusi terhadap energi level, sehingga secara teori energi bisa turun seperti itu. Dan secara cost kita kalikan, kalau sekarang jagung 5.600-an itu sekitar 1,6 kali 80 atau 1,6 kali 120. Apakah secara real itu bisa tercapai di Indonesia? Karena rata-rata tadi ditampilkannya data di luar Indonesia kan itu. Sementara di Indonesia dengan iklim yang berbeda ya, dengan distress yang berbeda, apakah kontribusi 80 kilokalori dengan 120 kilokalori itu bisa tercapai?
Oke Pak, dengan Pak siapa?
Pak Dede.
Oh ya Pak Dede. Nggak kelihatan Pak Dede, maaf gelap. Thank you Pak Dede. Joseph, the first question about the fetus that's produced with E. coli. Fetus with E. coli is reactive with the pepsin, right? Is reactive with pepsin. And what happened? Saya coba rangkum saja ya Pak ya. What happened if encapsulation, the most of the fetus in the market is encapsulation. What happened if the encapsulation destroyed by the pepsin? And the second, about the energy level that contribute from the Capsozyme is very so high. It's around 80 until 240. But that trial is coming from outside, it's not Indonesian. So, but what happened with Indonesian condition? Do you expect that number can we get that number?
Well, our phytase is not encapsulated. Okay, it's not encapsulated because one of the reasons here, phytases have an evolution on they call them first period, second, third generation, like a computer game. The thing that one of the reasons why the encapsulation appears was because at the beginning, many of the enzymes, as I showed before, do not have the same performance. So if there is destruction during pelleting process or during any other alteration, then you have less active ingredient in the gut, so less efficacy. Of course, probably today, that is not really linked to that, because we are so used, and mentally conception is, well, I have encapsulation, better protection. The companies keep protecting the phytase. But the first phytases, they were very unstable, as you mentioned, with the enzymes at gut level, and which they try to encapsulate it, also for temperature. One of the problems of encapsulation is not if you destroy it, is will be destroyed or not. because if the encapsulation remains, the enzyme will not work. So encapsulation only have to last enough to reach the intestine. So it really have to be destroyed in the stomach. If it's not like this, it's not good. But again, our enzyme do not have encapsulation. Is the thermal stability, as I said, is a fungi origin, although gene, E. coli gene recombinate, and it does have a quite good stability in the feed, okay, with pelleting. So I would say no problem. The second one,
About the energy that from the trial is coming from Indonesia.
okay,
But
okay.
how about Indonesia condition?
Yeah.
Do you think it will be?
But yeah, that's a question that I get everywhere, even in Europe. From Spain, from France, we all think that our conditions are different. Well, of course, our conditions are different, but our conditions are different with the feed, with the animal, with many things. Okay, but we all use the same raw materials. So, and one of the things that I mentioned before is that these tests are just to provide support on the matrix that we will decide to apply. Well, of course, you saw that there were up to 200 kilocalories. I will never suggest 200, not anywhere, because to do that, we were surprised in that trial as well. That happens afterwards. You never imagine that your diet will be that limited or that improved. So what it teaches you these things is that the enzyme is able to obtain benefit from the substrate that you are providing. So in our case, our matrix, I said, is 85 kilocalories, which is more than enough. Probably you will obtain more, but is a good thing. This is also an aspect that the enzymes compete in the market. Some enzymes, they say 60 kilocalories, some enzymes say 50 kilocalories, some enzymes, that is something, they have their own decision, but we are very confident that these trials produce all of them in India with India conditions, nothing special. They behave in the same way that when we produce in Thailand or in China, or when we produce them in Europe as well. Because at the end, the only difference is the nutritionists that make the diet. That is the one that make the difference. If you have a good nutritionist, doesn't matter if it's European, Indonesian, or Chinese.
Jadi pada intinya untuk mereformulasi dikembalikan lagi kepada nutrisionis atau formulator. Dari trial tadi hanya menunjukkan bahwa ini kerja loh, enzim ini bekerja. Even itu tadi kita lihat bahwa dengan pengurangan energi dan protein level sampai dari 2% sampai 4%, bahkan mencoba replace dari jagung ya. Total jagung diganti dengan wheat, terus kemudian soybean sebagian diganti dengan rapeseed meal, itu ternyata performa juga tidak terganggu. Kembali lagi untuk berapa energi yang kita pasang dalam formulasi dikembalikan lagi kepada formulator maupun nutrisionis, confidence-nya di berapa, karena dengan experience yang sudah sering dilakukan, kira-kira berani dipasang atau di set pengurangan di level berapa. Tadi hanya menyampaikan bahwa dengan ekstrim sampai 4% pengurangan energi dan protein level itu angkanya seperti tadi. Satu pertanyaan lagi, satu orang lagi penanya.
Untuk selanjutnya pertanyaan online.
Oke.
Baik. Bisa
Silakan.
di-show untuk pertanyaan yang ada di Zoom. Dari Bapak Dr. Hewan Purwono, menurut Bapak apa penyebab utama feed passage, ketidakmampuan mencerna atau adanya gangguan patogen? Dan juga dari Irhamni Syarif, CJ Feed and Care, tadi saya sekilas menyimak bahwa kandungan NSP merugikan bagi unggas, sedangkan NSP ada dua tipe, yaitu soluble fiber dan insoluble fiber. Apakah semuanya merugikan bagi unggas? Lalu antara pemberian multi enzim dengan single enzim, manakah yang lebih bermanfaat bagi unggas?
Ditujukan ke Pak Nanu.
Boleh bergantian mungkin Bu?
Bapak Ibu, termasuk yang bertanya di WhatsApp, di Zoom. Jadi mengapa kemudian ketika ada NSP jadi lengket? Karena memang ada ikatan tempat glikosidik ya. Kemudian konsistensi itu menjadi lengket-lengket begitu. Jadi glutinous, jadi lengket. Sehingga kemudian mirip-mirip dengan pati kanji yang tadi saya gambarkan, diberi air kemudian dihangatkan maka dia akan jadi lem. Nah itu pula yang terjadi di unggas ketika di pakan itu didominasi oleh bahan pakan yang kaya akan NSP seperti jagung dan gandum, ya, wheat, barley. Ternyata karena arabinoksilan, beta glukan itu tinggi, maka kemudian menjadi konsistensinya menjadi gel, kemudian lengket, kemudian more viscose, lebih lengket begitu. Nah, gara-gara lengket ini kemudian jadi laju pakan atau laju digesta dalam saluran pencernaan menjadi semakin lambat ya. Sehingga kemudian masa tinggal di dalam saluran pencernaan menjadi lebih lama. Nah, ini ternyata menstimulasi pertumbuhan dan kolonisasi patogen. Dan sekali lagi semakin banyak patogennya semakin rugi ya, karena kemudian patogen mensekresi atau menghasilkan metabolit yang berefek toksik atau yang kita kenal dengan istilah toksin tadi itu. Nah, jadi itulah kenapa ketika kita ribut dengan enzim ini karena memang pakan-pakan sumber energi seperti gandum dan jagung ini memang kaya akan energi, tetapi juga kaya akan kelemahan. Salah satunya adalah NSP tadi itu. Maka dengan penambahan NSPase diharapkan problem tadi terurai sedikit demi sedikit sehingga kemudian laju pakan dalam saluran pencernaan menjadi lebih cepat, kemudian masa tinggalnya lebih pendek, kemudian patogen tidak sempat berkembang biak semakin banyak, kemudian efek buruknya menjadi bisa dikurangi. Singkat seperti itu.
Mohon diperlihatkan kembali yang pertanyaannya, Pak. Pak Nanung ini masih tentang NSP ya, nomor 2. Let's talk about soluble and insoluble NSP. Is all the fiber and insoluble is bad effect for the poultry, and then how about multi-enzyme and single enzyme? Which one is the most beneficial?
Well, we have about the NSP, as you recall, we had to classify several molecules, beta-glucans, arabinoxylans, galactomanans. All of them, the main problem that it creates is that they produce gelification. So in water, they cannot properly solubilize like sugars, get diluted properly, and they get gel formation. That gel formation, what it creates is disturbing absorption of nutrients. So that is the main thing. So I would say there are raw materials that they have more these insoluble products that they produce the gelinification, and others they have more soluble NSP. I would say that Sergi showed before that corn does have NSP, but this is less problematic because it's easy solubilized, don't produce gel. But wheat and barley is the other way around. So the enzyme, what it does is they break a little bit. They don't need to destroy everything, but they do produce, a less gel, or as we also know, the viscosity. So that's a way. That is one of why it's so important working with these enzymes. Okay, but keep in mind with chitinases of these products, you don't get extreme unless you are really working with barley 60% or 70% inclusion, which is not usual. I would say so. Unsoluble NSP are the worst than soluble. And then the other question, the multi-enzymes.
About the multi-enzyme and single enzyme.
Well, this is a tricky question because many enzymes you have better should work. Okay, that is true as long as you provide enough active ingredient of this enzyme. If you only, introduce few units in a huge range of enzymes, that will not be. So that's why we all companies fight or work in order to preserve activity. We encapsulate them. We guarantee the activity. We confirm that activity will be there, because it's not the same that if you just say I have chitinases, proteases, beta-glucanases, but you don't mention how it is. That is the tendency of many of the multi-enzymes. Okay, if a multi-enzyme contains enough quantity of phytase, enough of protease, enough all of things, what happens? It's very expensive because you need to guarantee all this. There is no enzyme in the market today that, as a multi-enzyme, can guarantee this. And when I say that is no registration in Europe. Why in Europe is so important? Because in Europe, if you want to register an enzyme, you have to guarantee the units. You have to prove the presence, and that is one of the, let's say, way to measure the, the activity or the potential efficacy of the enzyme.
Oke, jadi untuk multi enzim yang kita ditekankan di sini adalah sepanjang kita bisa tahu berapa unit dalam multi enzim itu, is okay. Dan seperti Pak Joseph bilang, untuk bisa menggaransi bahwa unit itu cukup dengan jumlah unit yang cukup, dengan jumlah enzim yang banyak, tentunya itu akan berimplikasi pada harga enzim yang sangat mahal. Sedangkan realita di market bahwa multi enzim itu adalah sangat murah, sangat paling murah. Jadi oke, that's fine menggunakan multi enzim sepanjang kita bisa yakin bahwa unit enzim yang di dalam multi enzim itu cukup untuk membreakdown substrat yang kita punya. Masih ada pertanyaan, Mbak?
Masih ada 2 pertanyaan lagi. Oke, ini untuk dokter Bapak Nanung ya. From Tri Rahayu, FP Unsud, berdasarkan pengalaman Bapak, berapa kira-kira kadar NSP yang tidak mengganggu laju digesta pakan di dalam usus? Dan lebih efisien menggunakan aditif enzim atau aditif mikrobial? Lalu, untuk pertanyaan kedua, dari Fromkas untuk Pak Nanung, apakah ada perlakuan khusus seperti perlakuan kimia fisik atau kimia dalam mengurangi kadar NSP pada pakan sebelum diberikan ke ternak, serta berapa minimal kadar yang bisa ditolerir? Dan apakah memungkinkan ketika pakan dari starch dicampur feed aditif herbal bisa membantu dalam mendegradasi NSP?
Baik, yang pertama mohon maaf saya belum tahu sampai saat ini berapa maksimal kadar NSP yang bisa ditolerir oleh ternak unggas. Maaf saya belum tahu ya. Jadi sebelum saya menjawab, ini jadi PR saya, coba nanti saya cari informasinya. Kemudian yang kedua, apakah ada perlakuan kimia atau fisis untuk bisa mereduksi NSP juga. Sementara ini memang kalau berbagai penelitian yang ada di publikasi ilmiah, di berbagai jurnal, sementara ini baru enzim yang bisa mereduksi NSP. Ya. Kalau herbal sampai saat ini masih sangat jarang, atau kalau tidak boleh dikatakan tidak ada penelitian yang menghubungkan antara penggunaan herbal untuk mereduksi NSP. Karena umumnya herbal itu arahnya bukan ke reduksi NSP, tetapi ke efek anti mikroba, kemudian efek antioksidan, antilipidemik, antikolesterolemik, kemudian untuk appetizer ataupun yang lain. Sementara ini sangat jarang, kalau tidak boleh dikatakan tidak ada penelitian yang menghubungkan antara NSP dengan penambahan herbal pada pakan. Saya tidak mengatakan tidak ada hubungannya, tetapi sampai saat ini masih sangat jarang ada peneliti yang mengkoneksikan bioeffication dari herbal untuk mereduksi NSP. Kira-kira demikian.
It's interesting about maybe you can also have some idea, Joseph, any treatment like chemical or physical treatment to reduce or to destroy the alpha galactoside. They ask about the how to destroy the NSP, but maybe you have idea how about the alpha galactoside.
Yeah. Well, there is already a treatment. Hamlet protein, they treat the soya to obtain soy protein concentrate. They remove the alpha galactosides in that way. But of course, it's expensive and it's a totally different approach. Also, you could get the soya and soak it in water during days, and you may also get remove of alpha galactosides. The first one is commercially feasible, but it changed totally what it is. It's a soy protein concentrate, which, as you may know, you add 1, 2, 3%. Very good, but it's totally different approach. The advantage, as Sergi mentioned it before, is with a simple application of enzyme, which is what we humans and animals do. We have enzymes. We have already the approach that we are doing is you eat whatever, you have enzymes inside, digest it, and you get the nutrients. So that is the idea. This is a simple way, the cheapest way, and you don't need to do or to afterwards, if you put it in water, soya, you need to remove the humidity, otherwise it will be molded. So no, there is not really an alternative to be processing. No alpha galactosides, neither the NSP. I mean, you can remove the whole of some raw materials, but it's, you obtain a product that is more expensive, and then you have a byproduct, and that byproduct you will use it sooner or later. So again, it's not feasible. So I would say using enzymes is a pretty good alternative. The only thing is you have to choose a good one. That's the only problem that we have with us.
Bapak Ibu, saya punya pemikiran begini. Apakah harus dengan mendobrak NSP yang ada di permukaan? Kalau misalnya tadi ditanya, adakah cara untuk membongkar NSP melalui perlakuan non-enzim, misalnya dengan perlakuan fisis maupun chemis? Maaf, saya tidak bisa menjawab, tetapi ada cara yang lain, yaitu dengan dipecah. Jadi ketika jagung dipecah, kemudian wheat itu dipecah, maka enzim-enzim yang lain itu bisa masuk ke dalam lewat jalan yang lain. Seperti ketika kita lockdown COVID ya, jalan-jalan ditutup, kita akan cari jalan tikus untuk bisa masuk. Nah, jadi ketika
maaf, jadi dipecah dalam arti partikel lebih kecil ya?
Iya, digiling ya. Digiling jadikan kecil, maka kemudian bagian-bagian yang semula tidak bisa disentuh itu menjadi bisa disentuh karena dipecah. Jadi kalau dobrak nggak bisa, lewat jalan lain. Ya kadang-kadang kan kita nggak kurang akal gitu ya.
Oke. Jadi untuk NSP memang tidak ada perlakuan lain ya, baik fisik maupun kimia. Sedangkan untuk alpha galactoside seperti tadi Joseph bilang bisa didiamkan atau direndam dalam air dalam beberapa hari. Tapi kita kembali lagi itu tidak applicable ya untuk di di industri feed. Secara teori ya bisa dengan cara perendaman. Cuman secara aplikasi itu sulit. Kalau di hamlet protein itu salah satu atau soy concentrate protein adalah salah satu soybean yang sudah di alpha galactoside-nya sudah di remove. Itu salah satu produk, tapi kan itu sangat mahal dan penggunaannya paling hanya 2-3%. Sedangkan untuk cara remove yang lain adalah tadi didiamkan dalam air selama beberapa hari. Jadi untuk galactoside ini satu-satunya cara adalah dengan penambahan enzim, itu yang lebih praktis. Oke, Mbak, sudah selesai. Saya kembalikan kepada MC. Terima kasih. Terima kasih semuanya. Semoga bermanfaat. Kalau masih ada pertanyaan, silakan disampaikan kepada tim Cita. Nanti saya akan sampaikan ke Joseph. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih kepada Ibu Yen, Bapak Nanung, dan Dr. Joseph. Tepuk tangan sekali lagi yang paling meriah. Oke, baik. Sepertinya ini adalah end of the session ya. Dan ini adalah sesi yang sudah saya tunggu-tunggu Bapak dan Ibu sekalian. Mungkin Bapak dan Ibu sekalian mungkin ketika ada ikut launching pasti menunggu sesi ini. Bisa ditebak ini sesi apa? Apa Bapak? Sebelah kanan saya, sesi apa Bapak? Door prize, bener nggak ya? Ini sesi door prize. Benar Bapak, kita akan ada lucky draw. Tepuk tangan dulu dong semuanya. Di lucky draw kita ini hadiahnya sangat wow ya. Bisa dibilang door prize-nya wow. Karena apa? Karena bukan hanya pemerintah saja yang bisa mengeluarkan hadiah-hadiah ini. Seperti Bapak Jokowi mengeluarkan sepeda, ini Cita Indonesia ITPSA mengeluarkan sepeda juga Bapak dan Ibu. Langsung saja sepertinya akan saya panggil untuk yang bisa mengambilkan lucky draw. Boleh saya minta lucky draw-nya Mbak? Saya panggilkan terlebih dahulu untuk yang akan mengambil lucky draw pada sore hari ini. Saya panggilkan kepada Bapak Firnanda Hapsara untuk dapat maju ke depan. Lalu saya panggilkan kepada Bapak Dominikus Niko. Kepada Bapak saya persilahkan. Masih ada Bapak Fauzan Latif. Dan yang terakhir, Bapak Sigit Purwadi. Saya persilahkan. Di atas Bapak. Monggo.
Iswandi PT MBS Mega Prayasa ya.
Alhamdulillah. Mungkin
Monggo Pak, ini gara-gara kita ngerokok di bawah tadi Pak kayaknya Pak. Rezeki Pak.
Ibu Ida Sria.
Bapak Bayu Indra Suja, Super Luas Jaya.
Ibu Eli dari KMS.
Kepada Bapak dan Ibu yang telah memenangkan door prize, silakan untuk dapat maju ke depan. Beri tepuk tangan sekali lagi yang meriah. Barang-barang di tengah sini. Agak rapat ke depan, ke tengah Bapak. Iya, bisa agak rapat. Lebih rapat lagi. Iya. Baik, tepuk tangan sekali lagi untuk para pemenang door prize pada sore hari ini. Kita foto bersama dulu Bapak. Bapak Nanda, mungkin boleh di sebelah sini. Ya. Bisa lihat ke kamera, senyum paling bahagia. Satu, dua, tiga. Cita Capsozyme. Tepuk tangan sekali lagi kepada pemenang door prize sepeda untuk yang telah datang pada sore hari ini. Lalu ada sisa satu door prize, ini akan diberikan kepada penanya terbaik di Zoom online yang akan diberikan oleh Ibu Yen Yen. Mungkin bisa ditampilkan siapa penanya terbaiknya. Mungkin bisa ditampilkan yang tadi, Mas. Oke, ini dia untuk penanya terbaik dari Irhamni Syarif CJ Fit and Care. Silakan, mungkin bisa difoto dulu untuk Ibu Yen Yen. Apakah ada perwakilan? Ada, ternyata ada perwakilannya. Monggo Bapak. Alhamdulillah. Sudah? Mungkin mau, iya. Terima kasih. Silakan kembali ke tempat. Terima kasih. Itulah tadi lucky draw yang telah kita laksanakan. Selanjutnya akan ada launching ceremony dan juga thank you note oleh Bapak Dominikus Niko. Tapi sebelum itu saya ingin meminta tolong kepada Ibu dan Bapak sekalian untuk pengisian form offline untuk event feedback pada hari ini bisa di-scan di barcode yang tertera di meja dan mengisi form atau mengisi event feedback yang ada di kertas di atas meja. Bisa diisi dulu. Lanjut untuk yang online, kita bisa mengisi form yang ada, kami sudah sediakan di question box. Dan untuk materi yang ada pada hari ini akan dikirimkan sesuai dengan email yang sudah disubmit dalam form yang sudah Bapak dan Ibu submit untuk event feedback hari ini. Selanjutnya akan ada launching ceremony dan thank you note oleh Bapak Dominikus Niko, Cita Indonesia. Kepada Bapak Dominikus Niko, saya persilahkan.
Oke, baik. Selamat malam. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera buat kita semua. Mohon maaf saya agak udah waktunya mau dekati maghrib ya. Pertama-tama kami ucapkan terima kasih yang sebesar-besarnya kepada para bapak ibu yang menghadiri acara ini, baik acara offline maupun online. Ini acara kedua kita untuk offline dan saya berterima kasih karena semakin kesini situasi semakin membaik dan saya pikir sudah mulai lancar ya. Semoga ke depan kita bangsa Indonesia semakin tambah normal saja. Oke, also we are many thanks for our speakers, Bapak Dr. Nanung Danardono, Dr. Sergei Kane, and Dr. Joseph. Many thanks for your presentation dan Bu Yan, kami sangat terima kasih atas kerjasamanya kali ini. Semoga ke depan kita semakin membangun sinergi semakin lebih baik. Oke, seperti diinformasikan tadi bahwa kita akan ada launching information ya. Jadi dalam situasi, dalam hari yang membahagiakan ini, ada pengumuman penting yang ingin kami sampaikan. Ada hal yang membahagiakan yang ingin saya sampaikan. Ada dua personil yang akan masuk dalam company ini. Dua orang yang saya yakin di industri ini sudah malang melintang. Makanya ini momen yang membahagiakan bagi saya untuk mengumumkan di sini. Mungkin yang pertama dulu kali ya. Seorang pria. Sampai sekarang pria ya mungkin masih ya. Beliau udah lebih dari 25 tahun di industri ini, terutama di animal health. Banyak bergerak memang semuanya di vaksin bisnis, sehingga kami yakin beliau akan sangat membantu kami untuk membesarkan perusahaan ini ke depan. Please welcome Bapak Dr. Hewan Luki Rusmawan. Nah, Bapak Luki Rusmawan ini ke depan akan membawahi Direktur untuk Animal Health di Cita Indonesia. Yang kedua, sekalian supaya maju juga, kali ini seorang putri, sama beliau udah hampir 25 tahun malang melintang di industri ini, sama seperti Ibu Kartini ya, harum namanya di industri ini. Saya yakin juga bahwa beliau akan sangat berkontribusi untuk membesarkan perusahaan ini. Please welcome Bu Retno Arini. Oke, untuk teman, karena waktunya singkat, saya berikan waktu welcome speech untuk Bapak dan Ibu berdua.
Oke, Assalamualaikum warahmatullahi wabarakatuh. Ya, saya terus terang senang ya bergabung dengan PT Cita Indonesia, dan saya harap grup kita ini dapat memberikan kontribusi yang lebih besar kepada Bapak Ibu sekalian, dalam arti bisa menjadi one stop solution. Karena yang saya pegang ada animal health business, jadi kita akan menuju ke arah obat-obatan dan desinfektan dan juga vaksin ke depannya. Jadi sekali lagi terima kasih. Semoga kita dapat memberi kontribusi lebih banyak. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Menambahkan apa yang sudah disampaikan oleh Bapak Luki, semoga saya selalu pribadi bisa menambahkan warna yang lain di Cita Indonesia Group, dan semoga Cita Indonesia Group lebih berkembang optimal di kedepannya dengan kehadiran kami berdua. Tolong disupport untuk kita semuanya. Thank you.
Oke, mungkin tambahan, Ibu Arini akan membidani Direktur Feed Aditif di 1000 Cita. Baik, mungkin sekalian saya ditemanin, sebelum saya tutup, nanti teman-teman atau bapak-bapak dan ibu sekalian akan ada, tadi kita display ada beberapa merchandise ya, ada salad bar dan juga produk herbal dari kita, itu bagian dari kreasi di Cita Indonesia. Mohon nanti dinikmati Bapak dan Ibu. Untuk salad barnya kita ada 2 tempat, di Jakarta Selatan dan di Gading Serpong. Namanya untuk salad barnya adalah Kale Green, sedangkan untuk herbal drinknya adalah Rutsi. Rutsi sendiri kemungkinan akan kita launching di bulan depan. Baik, tanpa mengurangi hormat, karena waktu sudah mepet mendekati maghrib, kami mewakili manajemen sekali lagi mengucapkan terima kasih atas waktu dan kehadiran Bapak. Kita bertemu lagi di acara yang lain dengan acara yang semoga lebih baik. Sekian dari kami. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Bapak Dominikus Niko atas closingnya. Selanjutnya akan kita saksikan bersama, yaitu video launching Cita Indonesia, ITPSA, Capsozyme, SB+.
Kesehatan usus ternak sangat penting karena selaras dengan optimalnya produktivitas ternak. Dengan tidak adanya antibiotik dalam pakan, maka menimbulkan tantangan berupa kualitas bahan pakan yang tidak stabil, faktor anti-nutrisi, racun, dan mikroba patogen, mikroflora yang tidak seimbang, dan nutrisi yang tidak tercerna. Menambahkan Capsozyme SB Plus di bahan pakan yang berbasis corn soy diet dapat meningkatkan kecernaan nutrisi dalam konsep AME atau Absorption, Metabolism, Excretion yang seimbang. Formulasi pakan yang menggunakan penambahan Capsozyme SB Plus tidak hanya penghematan biaya pakan yang besar, tetapi juga menjaga performa yang positif pada hewan ternak. Capsozyme SB Plus merupakan kombinasi sinergis alpha-galactosides dengan silanase dalam memecah antinutrisi terutama alpha-galactoside. Alpha-galactosides dapat menyebabkan kembung, radang usus, mengurangi penyerapan nutrisi, stimulasi kekebalan tubuh yang berlebih, sehingga penyerapan energi terganggu. Pada alpha-galactoside terdapat 3 struktur, Strachios, Ravinose, dan Sucrose. Strachios dan Ravinose dapat menurunkan kecernaan nutrisi dari konsentrasi protein yang terkandung dalam SBM dan beberapa sumber protein dari tumbuhan lain. Capsozyme SB Plus dapat mengurangi Strachios dan Ravinose hingga 50% dan meningkatkan kecernaan nutrisi hingga 8%. Dapat menurunkan FCR pada ayam broiler hingga 4,7% dan 7,7% pada babi, bahkan dengan menggunakan komposisi pakan yang kurang baik secara kecernaan nutrisi. Pada ayam petelur, dapat mengurangi konsumsi pakan sebesar 2,6% dan meningkatkan produktivitas sebesar 5,2%.
Bapak dan Ibu, kepada Bapak dan Ibu, monggo. Mari kepada Bapak dan Ibu sekalian, kita akan mengadakan foto bersama. Saya persilahkan untuk dapat menuju stage. Saya persilahkan kepada Bapak dan Ibu sekalian. Mungkin bisa ada yang di atas dan di bawah. Monggo silahkan. Bapak dan Ibu bisa di bawah dan di atas. Baik. Yang sebelah sini agak kosong, mungkin bisa di sebelah sini. Saya mungkin bisa join di pinggir sini. Sudah masuk semua di frame? Sudah in frame semua, Mas? Baik, oke, kita hitung. 1, 2. Lagi, 1, 2, 3. Mungkin gaya apa, Pak? C? Oke, baik, kita C. 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 Baik, terima kasih sudah semua ya. Terima kasih kepada Bapak dan Ibu yang sudah hadir. PT Cita Indonesia. Terima kasih kepada Bapak dan Ibu yang sudah hadir pada acara launching Cita Indonesia.
Selamat datang di Cita Indonesia. Cita Indonesia memperkaya kehidupan dengan memberikan produk dan layanan bernilai. Sebagai mitra pilihan Anda, kami menyediakan solusi nutrisi dan kesehatan. Cita Indonesia adalah brand perusahaan yang beroperasi melalui 4 segmen bisnis: sumber herbal dan pedagang aditif pakan, solusi pertanian, teknik, konstruksi, dan logistik, serta retail. Meskipun masing-masing dikelola secara mandiri, berbagai lini bisnis tersebut disatukan oleh nilai dan visi yang sama. Kami berkomitmen untuk memiliki semangat juara karena membantu kami menjaga kemampuan untuk memberikan solusi dan menghadapi rintangan. Kami berkomitmen pada integritas karena integritas menciptakan reputasi kami dan menentukan bagaimana kami berperilaku secara internal